Hello guys, welcome back to my channel, Maison African Motives, still working on O-level mathematics. So in this platform, guys, we shall focus on the question paper, which was written November 2014, as we can see, it's paper 2. So we're just going to focus on the full paper, this one. So I've got our paper 2 here. So as we can see, guys, we have our paper and everything is actually the additional materials. Make sure you've got everything: the answer paper, the geometrical instruments, the graph paper, which is 2 sheets, the mathematical tables, the plain papers, which is 2 sheets. And I think that's what is important. And also make sure that you read the instructions, all right? Especially here on the omission of essential working, which will result in loss of marks. And also if the degree of accuracy is not specified in the question, and if the answer is not exact, answer should be given to 3 significant figures, and in degrees should be given to 1 decimal place. So if you're dealing with degrees, make sure that your answer is given to 1 decimal place, but anything, you leave your answer to 3 significant figures. So that was important on this part. And let us quickly to the first part of the question. I asked to simplify, giving your answer correct to 3 significant figures. So this is paper 2, guys. It's just multiplication that you're doing, which means you're just using your calculator to multiply. That is your answer. So here we're just going to insert our values. That is 3,27. So it's 3, 27 multiplied by 0,59. So if multiplied by 0,59, we are going to get 1,92, something like that. Okay, so we're going to get something like 1,2, that was 9293. So if you multiply these two numbers, we are going to get 1,9293. But now correct to 3 significant figures. So just round off your answer. That is to 3 safe with counting the whole numbers. So if 1, 2, 3. Remember, significant figures, these are all numbers that you're dealing with. You're dealing with all numbers. All right. So if you round off, we are going to see that the 9 here is going to affect this and changes to 3. So that means it's going to be 1,93. All right. So that is to 3 significant figures. Then find the lowest common multiple. That is the LCM of 72 and 96. So remember, LCM, all we need to write these numbers as product of their prime factors. So I'm just going to put this aside. So we've got 1b. So we've got the numbers 72 and 96. We want to find the product of the prime factor so that you can find the LCM. So let us start with the 72. The smallest number that we can use is 2. 2 into 72 divide 72 divided by 2, that is 36. Divide by 2, 36 divided by 2, that is 18. 18 divided by 2 is 9. Then 2 is no longer possible, so we're going to use 3. 3 into 9, that is 3. 3 into 3, that is 1. Okay, we do the same here on 96. The smallest number is 2. 96 divided by 2 is 2 into 9, that is 4, and for remainder of 1. 2 into 16, which is 8. 2 into 48, that is 2 into 4, that's 2. 2 into 8, that is 4. You can divide by 2 again. 2 into 2, that's 1. 2 into 4, that's 2. By 2 again, that's 6. By 2 again, that's 3. 3 into 3, that is 1. Okay, so I'm just going to write this as product of their prime factors in terms of powers. Yes, we can write these numbers. 72 is this and this and this. Okay, it's fine, but I'm just going to write this in short. That is what am I going to use? 72 is equivalent, as you can see, is 2 times 2 times 2, which is 3 times. So it's 2 to the power of 3 times 3 times 3, which is 3 to the power of 2. Then on 96, 96 is 2 times 2 times 2, which is 4 times, 5 times actually, it's 5 times. So it's 2 to the power of 5 multiplied by 3, which is just 3 to the power of 1. Okay, so remember LCM, guys, I told you that you have to take everything that is present, and taking everything, you're going to take the one that is with the highest power. So you look for the highest what? Powers. Okay, so the highest power on 2 is 2 to the power of 5. So that's what you're going to have in this case, which is 2 to the power of 5 multiplied by, in terms of 3, this is our highest power, which is 3 to the power of 2. So you're going to multiply by 3 to the power of 2. Okay, so from a calculator, you can just simplify this direct, guys. That is 2 to the power of 5, whatever that we get here, we multiply by 3 to the power of 2. That was 3 to the power of 2, like this. Okay, so we're going to obtain 288. So you can just multiply these two, that is 288 All right, so that's what you're going to have as your LCM. You can just multiply 2 to the power of 5, that is 32. 32 times 9, which is going to give us 288 if you multiply these two. So that is our highest common factor. If it was the HCF, let's just say the person was also asking us to determine the HCF. Okay, for the HCF, this is what you're going to do. The number has to be common, but this time you take the one with the lowest or the smallest power. You're going to focus on the smallest powers, okay? So 2 is common, yes, but which one is the smallest power? That is 2 to the power of 3. 3 is common also, but which one is got the smallest power? 3 to the power of 1. So you can simplify 2 to the power of 3, which is 8, times 3, which is something like 24, something like that. So that was your HCF. If the question was actually asking for the HCF, that is what you're going to do. Okay, so that is the case. So I'm just going to change this background a little bit so that maybe I can focus fine because it's affecting me here. Okay, so that is what we are going to have actually in this concept. So let us just cross-check the other part here. All right, so on C, convert or express this number to a number in base 5. So remember, guys, to convert to base 5, all you need, we can convert to base 10. Then from base 10, we can convert to base of 5, depending on the way that you actually use the two. Okay, so in this case, I'm going to convert to base 10, then to base 5. So you saw the number there. All right, so from our number, I'm just going to have this here. All right, so we are given the number which was C, that was 1, 0, 1, 1, 1 again in base of 2. Okay, so this is the number that we have, and we're supposed to convert to base of 5. All right, so to base 5, this is what you're going to do, raise to the powers of 2 so that we can convert this to base 10. Remember, we can convert this to base of 10. All right, so to base of 10, that is going to be here. 2 to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4. All right, so that means I'm just going to write here. Okay, I'm going to write this as 1 times 2. Okay, I didn't change here. Let me just change. All right, so I'm just going to write this as 1 times 2 to the power of 4 from this one, then plus 0 times 2 to the power of 3 plus this is 1 times 2 to the power of 2, so it's 1 times 2 to the power of 2 plus 1 times 2 to the power of 1, 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Remember how you convert to base 10. All right, so from this part we can simplify further. That is 2 to the power of 4, which is 16. 16 times 1 plus 16 plus any number times 0. Whether we know the number, but any number times 0 is what? 0. 2 to the power of 2, that is 4, 4 times 1, which is 4, plus 2 to the power of 1, that is 2 times 1, which is 2, plus 2 to the power of 0, that's 1, 1 times 1, which is 1. So you can add 16 plus 4, that's 20, 22, 23. So you're going to have 23, which is in base of 10. So it's now easier for us to convert this number to base of what? To base of 5. Remember, you're supposed to convert this to base of 5. So checking here back, we said we need to convert to base of 5. All right, so that's where we are now going to divide by 5 throughout this number, noting the remainder. So remember, you divide by the base throughout, noting the remainders down. So you're going to divide by 5, noting the remainders. So it's 5 into 23, noting our remainders down. Okay, so 5 into 23, that is 5 into 20, that's 4, remainder 3. 5 into 4, that's 0, remainder 4. So that's what you're going to have. So this becomes a remainder. And remember, you take your answer from the bottom, going upwards, it's going to be 4, 3 in base of 5. Okay, so that is what we had in this case. It was just converting to base of 5. So what we needed was to convert to base 10, then from base 10 to base 5. Okay, so that's how actually they can have these questions. So let us see the other part. A train that is scheduled to arrive in Blawayo at 0027. So this one I'm just going to write so that it cannot affect us here. All right, so the train was actually scheduled to arrive in Harare at in Blawayo, sorry, at 0027 hours. It is delayed by 3 hours, so it's being delayed. So which means instead of arriving at 12, it's going to extend the time to another. So a delay, you add the time, you don't subtract, you add the time if it is a delay. So it was supposed to arrive at what? At 0047. Then it was delayed by how many hours? It was delayed by 3 hours 47. So we add 3 hours 47 from that. So it's 3 hours 47. That was 47 also. It was 27. Let us suppose it can't be 20. So it's 27, this one. So it's 0027 here. All right, so this is 27. So we can add the delay, just like maybe you're going to school. You're supposed to go to school. You're supposed to arrive or to start your class at 8. Then you delay by 10 minutes. If you delay by 10, it doesn't mean that you're going to add to say you're supposed to be at school at 00 as at 080. Then you delay by 10 minutes. You add the time that you delayed with. So which means you arrived at school at 8:10. That is what it means when you delay. But if you arrive early, it means you're going to subtract. You're supposed to arrive at 8, then you arrive 10 minutes earlier. You subtract 10 minutes. So a delay you add. So that is what you're going to have there. So that is, we just add this 2, 7 plus 7, that is 14. 1 here, that's 4, 6, 7 again. 3 plus 0, that's 3. Then you could see 0 there. But take note, 073 is a time. Yes, it's time, but take note about this number. 74 is actually bigger than 60. So you have to subtract until we get a number which is less than 60. So 74 minus 60, that's an hour. 60 is an hour there. So if we subtract, you're going to get 14. So here we're going to remain with 14. The hour that we have taken, which is 60, representing 1 hour, we are going to add to this 03. So if we add 1 here, we are going to have 04. So which means the train arrived at 04:14, which is in 24-hour notation. Okay, so that is a 24-hour notation. So you are given time here in 24-hour notation. It's best for you to also write your answer in what? In 24-hour notation. Okay. The number 2, solve the equation. Okay, so that is the equation that you're given to solve. So as for equations, guys, it's best for you to work with the condition that you are best at. It depends with what you're given. So here I'm just going to rewrite the question as we're given. So this is 2a. All right, so that is our 2a. So we're given it was 2 over x minus 1 over 4, which is equivalent to 3 over 5x. Okay, so there are so many ways of you solving this. You can combine clear fractions. So on the previous questions, we did a part of clearing fractions. So this time I'm going to use another method. This time I'm going to add first. I'm going to combine these two, okay? I'm going to combine these two here. Okay, so what do I do to combine these two? I just have to find the LCM of x and 4, which is 4x. Okay, so let's divide 4x, divide by x, that's 4. As you can see, x and x will cancel, remain with 4. So it's 4 times 2, which is 8, minus 4x divided by 4. 4 and 4 will cancel, you remain with x. So x times minus 1, that's minus x, which is equivalent to 3 over 5x. So these two, I've combined them, and here I can now cross multiply. As you can see, you can cross multiply. That means 5x is going to multiply x minus 8. So it's 5x into 8 minus x, which is equal to 4x times 3, which is 4 times 3, that's 12. Okay, so you're going to obtain 12x. So from there, as you can see, now you have in brackets where you can expand your brackets, in this case, by what? By 5x here, so you're going to have 40x. By 5x here, you're going to have minus 5x squared, which is equivalent to 12x. So that's the type of equation that we are now having at the end. So from this part, what can we actually do? That is the question. I can collect like terms. As you can see here, we can actually collect like terms. Negative 5x squared. Okay, we've got 40x here plus 40x transpose. The 12x to that side is going to be a negative, which is negative 12x is equal to 0. All right, so let us collect like terms. That is negative 5x squared. If we are to simplify, put 40 minus 12. 40 minus 12, that's something like 28. We're going to have 28 here. Okay, that's 40 minus 12. All right, put 40 here minus 12. All right, which is 28. Okay, so that is 28 here. So we're going to have 28x is equal to 0. Yes, we have a quadratic equation, but this one, how do we solve this? We can simply solve by what? By factorization. So this type of an equation, actually, you can do by factorization. If you are to cross-check, x is common here. So that means I can factor out x, which is common. So if I factor out x, it's going to be minus 5x squared divided by x, which is minus 5x 28x divided by this x, which is plus 28, which is equal to 0. So take note at this stage, if you're given these two, you're going to say one of these should be equal to 0. So x should be equal to 0, or minus 5x plus 28 should be equal to 0. So if x is 0, what about the other part? Minus 5x should be equal to what? 28 to that side is going to be negative 28. So x is equal to 0, or minus 5x here. How can we get rid of the negative? I'm just going to divide by what? By negative 5 here, by negative 5, by negative 5. So this can cancel. So that means our x is going to be negative and negative cancel. So it's going to be 28 over 5, of which 28 over 5 is 5 into 28. 5 into 20, that is 25, which is 5. Remainder 3 over 5. Okay, so these are the values of x that we are obtaining. But now let us cross-check, and do these values make sense? Okay. If we are to cross-check when x is equal to 0, it is not going to make sense. Why? Because we can never have a condition whereby the denominator here is equal to 0. We do not have something like 2 over 0. It's actually infinite. We do not have an answer for that. The denominator is not supposed to be equal to 0. So if you see here, it's also 0 here. So which means x can never be equal to 0 on this one. So which means on our answer here, we are now therefore concluding to say therefore, okay, so we're just going to conclude here, therefore, our x is equal to 5 and 3 over 5. X cannot be equal to 0 here. So x can never be equal to 0 because we do not have that in the denominator. Okay, so this was the value of x that we could have determined. Okay, so maybe just cross-check, guys, the method. Here we have to combine these two. To combine. Okay, maybe someone said, I just want to expand brackets. I do not want to combine. I want to expand those fractions. What are you going to do? Still, we're going to have the same thing. It was 2 over x minus 1 over 4, which is equivalent to 3 over 5x. So this is another method. So using this method, you're going to clear fractions. All right, we are going to clear fractions. So how do I clear fractions? I have to cross-check for the LCM, which is the LCM of these fractions, the denominators, which is x, 4, and 5x. What is the LCM of this? As you can see, it's just multiply here, 5 times 4, that's 20, and that's 20x, that's our LCM. So you pick the smallest term that you can multiply with. So your LCM in this case is 20x. This is our LCM. So we multiply each and every term by 20x. Multiply by 20x here, multiply by 20x here, multiply by 20x here. Okay, so that's what you're going to do. So x and x will cancel. You're going to cancel this also. The same 4 into 20 here, that's 5. The x and x will cancel. 5 into 20, that is 4. Okay, so that's what you're going to have at the end. So now let us take this. We cancel this, we are left with 20. So 20 times 2, that is 40. Here we've cancelled, we got 5. So it's minus 1 times 5x here. Minus 1 times 5x, which is minus 5x, equal to 3 times 4, that is 12. Okay, so that's what you're going to have at this stage. So minus 5x is equivalent to 12 minus 40. This is paper 2. There is no worry if you do not know this. Use your calculator here to simplify. 12 minus what? 12 minus 40, just like that. You get negative 28. Okay, so minus 5x is equivalent to negative 28. Then from there, we can divide by negative 5 both sides. All right, divide by negative 5, divide by negative 5. So x is equivalent to what? That answer that we got, negative 28, we divide by negative 5. So by negative 5 here, we're going to get 28 over 5, or we convert 5,6, or you can convert like this, which is 5 and 3 over 5. So you're going to get 5 and 3 over 5. So as you can see, you're getting the same answer, just like what we got here, 5 and 3 over 5, which is the one that we got here on this part. So you have to analyze your questions. What am I going to use, and which method is the best for that? Okay, so that was actually what we had in this case. So our x was 5 and 3 over 5. Okay, so let's cross-check another question. Okay, let us just get back to our question here. All right, so the B part now is to factorize. So these ones, we can even do them here. Factorize 7x cubed minus 28x. Okay, so if we have to cross-check here, x is actually common. So I can factor out x here, which is common. So if I factor out x, what am I going to remain with? It's 7x. Okay, even 7 is also common here. 7 is common, as you can see, it's 7x, which is common. Okay, so 7x cubed divided by 7x is 7, and 7 cancel. X squared, x cubed here because it's x to the power of 3 divided by x. So it's going to give us what? X squared. So you're going to remain with x squared minus 28 divided by 7, that is 4. As you can see, x here and this x will cancel, so you're going to have something like this, okay? But inside this bracket, this is difference of 2 squares because this 4 is same as what? 2 squared, okay? So this is same as writing as x squared minus 2 squared, where I told you that once you can write in this case, we're going to take this x and what? And this 2. So our answer is going to be 7x into x plus 2. One bracket adds, another bracket subtracts. That's your difference of 2 squares. All right, so I think this one was clear. All right, so I'm going to have another one from this part here. I'm just going to erase so that we can work out the other one. So the other item now is item 2, which is 3y squared, whatever that we have there, 3y squared minus 5y plus 2. So how do I factorize this? Remember, there's a long method that you're going to use whereby you multiply the first term and the last term, okay? So if you multiply these two, you're going to have 3y squared times 2, which is 6y squared. So you're going to look for the factors of 6. But these factors, if you add them, they must give you this middle term, which is what? Which is minus 5y. So which are the two terms that we need? When we multiply them, they must give us 6. So there are so many terms. We've got 3y and 2y. If you multiply, you get 6 minus 3y and minus 2y. If you multiply this, you get positive 6. 6y and y. If you multiply this, you get 6 minus 6y and minus y. But which of these, when you add, you are going to get what? You are going to get negative 5y when you add. So as you can see, this is happening on these two, minus 3 plus minus 2, that's minus 5. So these are the two terms that we are going to replace now in the middle term. In place of minus 5y, so it's going to be 3y squared. In place of minus 5y, I'm going to substitute minus 3y minus 2y plus what? Plus 2. So remember, guys, I told you that at this stage, you are now having 4 terms. So since you are having 4 terms, you group them into 2. Okay, so in 2 like this, you now factor out the highest common factor here, which is 3y also. So 3y squared divided by 3y, that's 3 and 3 cancel. Y squared divided by y, that's y. Minus 3 divided by minus 3y divided by 3y, as you can see, this will cancel, you get minus 1. Okay, so remember the idea is to make sure that these brackets are the same. Whatever that we are going to get from this part, if I factor, I must get the same bracket as y minus 1. So what am I supposed to get? This is a negative. So for it to be a positive, because y is supposed to be a positive. So which means I'm supposed to factor it as a negative like this, negative 2. So that if I divide minus 2 and minus 2, I get a positive. So it's now y. 2 divided by negative 2, that's minus 1. Okay, so the brackets are the same. As we can see, this bracket and this bracket are the same. So what do? I just have to take that common bracket, which is y minus 1 into what is remaining. You are remaining with 3y minus 2. So these two, you open a bracket for them, you write them in one bracket, 3y minus 2, you're done. So that's your factorization. So that's what we needed, guys, to get 5 marks from item 1 and item 2 of this question. Okay, then the last part on question number 2 was to express as a single fraction in its less term. That is the same condition like what we did on that previous part where we had to express as a single fraction. So we said to express as a single fraction, all we need is to have the common denominator. So we've got 2x minus 3 and x. What is our LCM? That is our common denominator, which is x into 2x minus 3. So how do I go about it? Remember, we divide this LCM divide by 2x minus 3. So as you can see, 2x minus 3 will cancel. So you're going to remain with x. So it's going to be x times the numerator. Your numerator is what? X plus 2. So you multiply to x plus 2 minus the denominator here, divide by x. So as you can see, x here and x will cancel, but you don't cancel, you just know that these will cancel. So it means you remain with what? With 2x minus 1. So this 2x minus 1 has to be multiplied with the numerator, which is minus 1. So it's minus 1 times 2x minus 3, like that. Okay, so that's what you're going to have at the end. So from this part, we can expand whatever that we have. x and x here, that's going to be x squared. X and 2 here, that's 2x. Minus 1 times 2x, that's minus 2x. Minus 1 and minus 3, that's a positive 3. Everything over x into 2x minus 3. So you can simplify further. As you can see, these two terms can subtract, cancel each other. That is the 2x here and the minus 2x. So 2 minus 2, that's a 0. So you're going to remain with x squared plus 3. Everything over x into 2x minus 3, like that. So you're done. There's nothing that you can do from there. Just leave your answer like that. Okay, so that's what we had, guys. So it's a matter of working with more questions so that you can actually understand what is happening here. Okay, so number 3, we are now given a rectangle. So this is a rectangle which measures 6 centimeters by 8 centimeters by 6 centimeters to the nearest centimeter. Remember, guys, what I talked about on the degree of accuracy when you're dealing with estimations. When you're doing estimations, calculate the least possible value of area of the rectangle. So these values were rounded to the nearest centimeter, which means to the nearest what? To the nearest whole number. That is what it means. So the numbers were rounded off to the nearest whole number. So what are the dimensions that we had before? Remember, it's 8 by 6. So which means we have got something like this. That's our rectangle, which measured what? 8 centimeters by 6. So the 8 before it was 8. What is the least possible? Because we need the least. So the least value is going to be 7,5. Okay, so remember it's just 0,5 less than that. Okay, and 6 here we had 6, which means the least value was going to be 5,5. If we round off 5,5, we get 6. If we round off 7,5. So if you do not understand this part, make sure that you watch the video where I did about the estimations. Okay, on this part, you can actually understand much better. Okay, so these are where the dimensions that we're going to have, and we know that area of a rectangle, that length times width, or length times what? Length times breadth. Okay, so our area is going to be length 7,5 times width 5,5. This is paper 2. This presentation is now on your calculator, multiply the two. 7,5. Sorry, that's 7,5 multiplied by 5,5 direct on your calculator. What are you getting as a decimal? That's 41,25. So you're going to have 41,25 square centimeters. This is area. Remember, area is measured in square units. So it's going to be square centimeters. Okay, so that was the idea there. So please, guys, understand the question, how you are given and how are you going to attempt that question. Okay, so let us move on to the B part. It's a set. Okay, that's a set here. It is given that the universal set has got elements. Take note, guys, how you are given this part. I'm just going to zoom a little bit. Let's hope it's not going to affect just a little bit. All right, something like this. Okay, so you're given there the values of x of the universal set. I want us to move slowly here, because that's where most of us we get challenged here. It's x is greater than 8, but less than or equal. There's a less than or equal to here, which is 16. And this x is an integer. Integers, we're talking about positive or negative what? Whole numbers. These are integers. All right. But our x is greater than 8. If you're talking about this x, start like this one. It's 8. Okay, let me just change this. No, the marker. It has to be changed here and then. Okay, so I think it can help. Let's get blue one is fine. Okay, here it's 8, which is less than x. It means x is greater than a. That is what it means. So 8 is not needed. So our x has to start from 9. These are the values. This is an integer that is greater than 8, which is 9, 10, 11, and so on and so on and so on. So that is where we are going to start the values of x. Okay, so that's what we need. So it means our here I'm just going to list all the elements here. Okay, so that is our universal set here. So we said we're going to start from 9. So it's 9, 10, 11, 12, 13, 14, 15. Okay, here it's less than, or there's an equal to there. That one is an equal to this. So which means 16 is involved. So we are going to take up to 16. So these are the elements of the universal set. Okay. Let's move on to A. A is such that our x is such that x is a square number. But remember, this A and B, they are subsets of the universal set. So which means they are supposed to be taken from this set here. So from this set that we have listed, which is our universal set, we need square numbers. And the square number is a number that when you determine its square root, like 25, square root of 25 is plus or minus 5. So 25 is a square number. The square root of that number is a whole number. You get a whole number. That means it's a square number, okay? Because you're talking of integers. So these are square numbers. You're talking of 9 because square root of 9 is plus or minus 3. We have got 16. Square root of 16 is plus or minus 4. So which means 16 is a what? 16 is a square number. So you've got 9 and 16. Okay, so let's talk about B also. The B here is X is said that our X is an even number. So you're talking of even numbers, those numbers that when you divide by 2, they are exact values. They do not leave a remainder. So we are talking about 10. We are talking of 12. We are talking of 14. We are talking of what? 16. These are the even numbers. Okay, so these are the sets, your universal set, your A and your B. Okay, so let us attempt the first question. Item 1. List all the elements of A. So here we have already listed our A here. We said it's 9 and 16. We have already listed, okay? Then item 2, number of elements in B. Already our B is here, but how many elements are there? 1, 2, 3, 4. The question is how many elements? That is the number of elements in B. So there are 4 elements, okay? Then item 3, show this information on a fully labeled Venn diagram. Okay, so we need to represent on a fully labeled Venn diagram. So this is it, guys. This is our information that we're going to put on our Venn diagram. So the first thing is to analyze is, do we have intersection of the two sets? Yes, if you cross-check here, 16 is common in A and B. Okay, so it means we are going to have our A and B like this, joined together. So this is your A, this is your B. So on the intersection, we have got 16. This 16 is found in both A and B. So you're going to write it in on the intersection, okay? Then in A, as you can see, in A, we are remaining with 9. So you're going to write 9 here. In B, these are the numbers that are remaining in B. We've got 10, 12, and 14. So you've got 10, 12, and 14. Then after filling this information, do we have elements which are not included, but they are in the universal set? They are here in this set. Do we have elements which are remaining? Yes, we've got elements, so many elements like 11, 13, they are not here. So those are the elements now that you draw, you indicate with this rectangle. That is where you have to draw now the rectangle to show those elements which are not part of what? Part of this set like that. So that's the universal set. So which are the elements which are not here? Okay, 9 here, we've got 9. Okay, so I'm just going to tick this 9. We have got 9 here, 10, we have got 10 here, 11. We do not have 11, so we're going to write 11. Okay, we move on to 12. We have got 12 here. We move on to 13. We do not have 13 here, so we write it outside. So it's 13. 14, we've got 14 here. 15, we do not have 15. So we're going to write this 15 anyway, as long it is outside of the set, right? Anyway, okay. 16, we've got 16. So that was going to be the Venn diagram. So this was the question which needed the Venn diagram. So your Venn diagram, these are the elements, how you're going to indicate them or to represent them. Okay, so I think it was clear, this one. It's just a matter of working with the questions, guys, as many questions as possible. So question 4, on question 4 there, it's a question on similarity, similar figures. I talked about this type of a question on another question paper, if you still remember, guys, if you're watching our videos, where I told you that there are some triangles that when you are to try to find similar figures, you have to work with the diagram the way that you're like this one. If you are given this type of, as you can see on this type of equation, it's not direct because here we need two triangles which are similar to triangle LMN, which is LMN. Remember, similar figures, they are equiangular. You take these ones according to equal what? According to equal angles. Those are similar figures. They've got equal angles. Okay, so this is what you're going to do. I want you to understand this part, guys. I talked about this in our other question paper, but I'm going to give another emphasis now. This is what you do. Since you are not given angles here, you are going to assume one angle of your choice. All the other angles, they are going to be taken from that angle. It's either you're going to assume that one in terms of a letter or whatever that you're going to have, but you're going to assume one angle of your choice. So this is one angle of your choice. But make sure that angle is an acute angle, guys. Why are we saying this angle has to be an acute angle? An acute angle, we are referring to an angle which is what? Less than 90 degrees. So any between 0 and 90, as long as it's less than what? Is less than 90 degrees. Why? Because we are in a triangle, guys, and it's a right angle triangle. So once this is 90, it means these two angles, they must add up to 90. So which means they are supposed to be less than 90 degrees. So you just assume any angle of your choice. Okay, so this is what I'm trying to say. I'm just going to assume in this case, let me just say I want to pick this angle of my choice, okay, which is 50 degrees. So this is my assumption. I want to make this angle M here to be. So you just assume any, you write it N, you can write it here, you can write it here, you can write it here, you can write it here. You just assume any of your choice. Then all the angles, they'll be created from that angle. Okay, so here I'm assuming let angle M here be equal to 50 degrees. It's an assumption that I've made for myself, okay? So I'm going to let this angle M to be equal to 50 degrees. So if this is 50 degrees like this, therefore, all the angles, they can be found now. So let us start with N. How are we going to find this angle N here at N? How are we going to find this angle N? So remember, we are told it's right angled at N at L. So it means the angle at L here is 90 degrees. So to find the angle N, we are going to use the bigger triangle, this bigger triangle, this one, okay? We know that angles in a triangle, they add up to 180 degrees. So angle N is going to be 180 degrees minus these two angles that we are given, which is 90 plus what? 50. So 90 plus 50 degrees, which is something like 140. So it's 180 minus 140 degrees, which is 40 degrees. Okay, so it means I now have the angle at N here, which is 40 degrees. You see, from one angle, you can feel the whole diagram. Okay, so let's move on to L. There are two L's that we have here, where there's this L in this triangle here, there's this L here. We know that this is P, guys, this is a straight line. So if this is 90, this is also 90 here. This is also 90 at P. This is 90, this is also 90. So you can find L. So using the same concept in L here, we saw that once we have got 90 and 40, which means this angle is going to be 50 here. We just subtract 90 plus 40, which is 140, then 180. It's going to be 130, then 180 minus 130, we get 50 degrees. So this is going to be 50 degrees. We find this remaining angle on L, which is on this side here, which is, we talked about this. If there is 90, 50, the remaining angle is going to be what? It's going to be 40 degrees, just like what we did here. It's going to be 40 degrees like this. All right. So these are the angles that we have. We have filled the diagram. So you just choose any angle of your choice, guys. After that, now we can have our similar figures. So this is what you're going to do, okay? I want you to be very, very clear here. Okay, sorry for that. Let me indicate like this. This is what you're going to do from this part, okay? Let us take our LMN. I'm just going to put it aside like this. All right. So let us take our LMN here. We said we want to find two triangles that are similar to triangle what? LMN. So this is LMN, okay? So now LMN is from the bigger triangle, this bigger triangle here, where L is 90 degrees from the bigger triangle. Now, this is similar, okay? This is similar to what? Okay, maybe you can just change the marker. Okay, it just saves after some time. Okay, so I'm just going to save. Okay, so this is similar to triangle. We have got two triangles, the first one and the other one. So I'm just going to put them together like this. Okay. The first one, we are saying L of the bigger triangle is 90 degrees. This is L of the big, which is 90 degrees. We are going to see that we have got two triangles that are being created. There is this triangle here. Let us call it triangle 1, and this one triangle 2. So from triangle 1, which angle is equal to L, which is 90 degrees? Because we said these angles, they are similar figures, they are equiangular. So you're now asking yourself which angle is equal to L, which is 90 degrees. So you can see there's 90 here on P. There's also 90 here from P. So from triangle 1, there is P, which is 90 degrees. From triangle 2, there is also P, which is 90 degrees. So take note, guys. Take note. We are taking these according to equal angles. Okay. Now let's move on to M of the bigger triangle. This is your bigger triangle. Your M is what? Your M is 50 degrees. So now you're asking yourself to say, which angle is equal to this M, which is 50 degrees? So that is what we need now. So from triangle 1, we are working from triangle 1, remember? From triangle 1 here, we need an angle that is equal to 50 degrees. And in triangle 1, the angle that is equal to 50 degrees is this one, which is at what? Which is at L. So this one is going to be PL. But from triangle 2, which is this smaller triangle, an angle that is equal to 50 is this M, which is 50. So this one is going to remain as it is, which is 50 at what? At M. So this one is going to be PM, okay? We move on to N, because remember, this is LMN. So from the bigger triangle of LMN, our N here is at this point, which is what? 40 degrees. So we need an angle equal to 40 degrees, okay? So from the first triangle, remember, this is our first triangle, this smaller triangle, this one. Which angle is equal to N, which is 40 degrees? As you can see, is that N again, is repeating. So there's nothing that we're going to do. It's going to remain as N. So it will be PLN. We move on to the second triangle, which is this smaller triangle. Which angle is equal to N, which is equal to N? Our N is 40 degrees. So which angle is equal to 40 degrees? In this small triangle, we are going to see it's L. The L that we're talking about is the L of the smaller triangle, this one. Don't confuse between the L of the bigger triangle and the L of this smaller triangle. So L, this one is also equal to 40 degrees. So it will be PML. Okay, so these are the two triangles which are similar to the first triangle. So our answers was going to be this one or this one. Take note, similar figures, you do not just write to say, if it is triangle PLN like this, you can write as PNL. This is wrong. Or you can write as LNLP like this. This is wrong. You take them according to the angles which are equal. So they must be like this. So these are the two triangles that we're supposed to have on our answers, okay? So that was our item 1. So I just hope with this explanation, guys, you can answer any question of this nature if you were truly with us here. Okay, so item 2, find PM. Okay, so this is our PM. I'm just going to remove this. Since we now have similar figures, this is no longer important, okay? So we now have our similar figures, so it's no longer important, okay? So like this. We want to calculate PM. So we have to ask ourselves, where do we have PM from these two similar figures? Remember, we've got these two figures, this triangle similar to this triangle. So you're going to see that PM is from this triangle, PML, from this one, PML. This is where we have got what? PM, PM, PM. Here we do not have PM. Okay, we do not have PM, but there is something that we have from this one, which is that we, from the information, if you have to cross check here, we put PN, that is 9 centimeters, LM, which is what? Which is 6 centimeters. So remember this, guys, I want you to understand this. Let me explain so that we can understand. Okay, these three triangles, this triangle, they are all similar. So you can take any ratio to say these two, they are similar to each other, or these two, they are all similar to each other. So on taking the triangle, which one are you going to use? Because remember, we are supposed to use ratio of sides. Remember, guys, I told you that from similar figures, the ratio of sides is equal. So on taking the ratio of sides, which triangles are we going to, because we are supposed to have two triangles. So far, PM is on this triangle. So therefore, I'm going to take this triangle. So I'm going to start with that one. Triangle PML is similar to which triangle that I'm going to use again. So I cross-check according to the information that I'm given. Here I'm given PN, which is 9. LM, which is what? Which is a 6, of which the LM that we have in this case is from this one, or it can be from, here we do not have L, but we have got PN. So which means we can also take this part that is called PN. You choose which one is best. So I'm just going to work with the first one, which is LMN. So we're going to come back to this one and see if you're going to get something. But for the meantime, let us use these two. Okay. So these are the two triangles that I'm going to use. From those answers that you got previously, you just pick which one is best. Okay. So this, let us have our ratio of sides. Remember, it's PM over the corresponding side, which is LM, which is equal to ML. So it's going to be ML over the corresponding side, which is MN. So this is MN, which is equal to PL. So this is going to be PL over the corresponding side, which is LN. Okay, as we want to calculate this PM, so it's not going to change. So PM over the corresponding side, which is LM. Do we have LM on our diagram? Okay, let's cross check. LM is there. From L to M, it's 6. So we are going to substitute 6 here. So it's going to be 6, which is equal to ML. Do we have ML? LM is the same as LM, guys. So it's going to be that 6 as it is again. Okay, over MN. Okay, so let's cross check our MN. This is our MN here. I want us to see what is happening with MN. MN is going to be taken. I want you to see clearly, guys. Please understand this part. Okay, this is your MN from M to N. It's a combination of 2 points from M to P, then from P to N. So from M to P is same as M is PM, right, guys? Writing PM, this one that we have here, writing it as PM or as MP is one thing. So which means it's a combination of PM and what? And 9. So these are the two parts we are going to add together to get MN, because here it's MN. Take note, guys, take note here, it's MN. So it's a combination of these two here, which is 9 plus PM. So this is what you're going to write your equation as. So it is going to be 9 plus PM. So it's 9 plus PM or MP. But you can't write as MP because here we want to calculate what? PM. Just write as PM, like the way that we're given here, PM. Okay. So as you can see, we formulated an equation. Therefore, what are you supposed to do? Solve for PM. Or you can introduce PM to say, let PM be equal to X so that you can solve properly. I don't know what is best for you, whatever that is best. So you can just let PM be equal to X. So if PM is equal to X, this means our equation can, this is just a format, guys, but you can use even that PM as it is. So if I let this PM to be equal to X, it means I'm going to be having X over 6, which is equal to 6 over 9 plus X. In place of PM, I'm substituting X. So how do I solve this? I can cross multiply. So you can cross multiply here. That's X is going to multiply 9 plus X. So it's X into 9 plus X, which is equivalent to 6 times 6, that is 36. Okay, so let's multiply 9 times X, that is 9X. 9X times X, which is X squared, is equal to 36. So as you can see, a formulated quadratic equation, which is going to give us X squared plus 9X transpose the 36 to the left-hand side, that will be negative 36 is equal to 0. So how do I solve this? As you can see, guys, the coefficient of X squared here is 1. So simply, I'm just going to introduce this. If the coefficient of X squared is 1, I'm just going to have 2 brackets, which I equate to 0 here. X and X, remember, we focus with the constant term, which is negative 36. What are the factors of negative 36? But if we add these factors, they must give us the negative, the positive 9. That is that is what we need. So we've got 12 and negative 3. 12 times minus 3 is minus 36. 12 plus minus 3 is 9. So you're going to add 12 plus minus 3. So therefore, each bracket is supposed to be equal to 0. So X will be equal to minus 12, or X will be equal to 3. But the X is a side, so X can never be equal to 12. So X is going to be equal to what? To 3. So remember we said PM is equal to X. So therefore, our PM is equal to, because X is representing PM, so therefore our PM is going to be 3 centimeters. So that's what you're going to have. Here's your final answer. So you have to write the actual answer. You can't have a side which is a negative. So our answer here cannot be equal to what? Cannot be equal to, okay, let's just save a little bit. All right, so here I'm saying our X cannot be equal to what? Cannot be equal to a negative. So therefore it is going to be a positive. So guys, there are so many ways. I don't know, on the comment section, let me know some of the ways that you could have done this question. I know you guys have got so many ways and so many methods, but the idea is, are we getting the same answer? That is the idea, okay? So I can just know on the comment section, guys, if there can be any other ways that you could have done. Okay, then on the other part, we're given now the D part, which is part of variation, but let's see how this variation was given as. We are given the B part, there is a variation there, which is the annual premium. Take note, this is the annual premium P dollars for a funeral insurance scheme varies jointly. So it's a joint variation, this one, okay? So it varies jointly as the square root of the edge, which is y. Take note the square root. So we have got two things here, p. So we are going to write this, p varies jointly, which means we've got two things here. So it varies as the what? The square root. So it's the square root of y here. And the number of dependents d. So joint variation, remember you multiply the two. So this one, you're just going to multiply to what? To d, which is the number of dependents, like that. So which means p varies with the square root of that. And we can actually introduce the constant. Remember, if you're given variation, you can introduce the constant. So that means here, p can be written as what? Is equal to, the moment you take off the variation, you're introducing the constant. So p is equal to k, the square root of y times what? The square root of y times d, or the square root of y d, like that. So y is the one that is under the square root, not d. Take note about the question. Okay. So now on this part, we are given now, remember p is the money, which is the what we are given, then y is the age, then d are the dependents. Okay. So here we are given that if a 25-year-old applicant, so which means we are given y here, with the 6 dependents, which means we are given number of dependents, which is d, pays $150, which means we are given p, which is p in what? In dollars. So this information alone from this part here can help us to find the value of k, because we are given the money, which is p, $150. So you just write as 150. The comma 00 is just a way of writing money. You don't use them when you're calculating. So you use the number, which is 150 here. So 150 is equal to k times square root of y. So you put square root of y here. Y is what? Y is 25. So square root of 25 times d, which is the number of dependents. There are 6 dependents, times the constant, which is k. So that's what you're going to have. So 150 is equal to the square root of 25, which is going to give us 5. And 5 times 6 here, which is going to give us 30. So we're going to have 30k. So to find k, we can divide by 30. We can divide by 30 here. This can cancel. So therefore, we can have our k here. If we cancel, our k is going to be 3 into 15, which is 5. Okay, so that means we can connect now the number, the premium, which is the p, to the number of dependents and the years, which means our equation now is going to be p is equal to, since we have the k, which is 5, so it is going to be 5 square root of y times d. Take note, y is the only part that is under the square root. So the question is asking us now, what is that premium that we are going to calculate the monthly premium for a 49-year applicant, which means the y, 49-year, we're given the number of years, which is 49. With the 4 dependents, we are given d, which is the number of dependents. We are given that y is 49. When y is equal to 49, and d is equal to 4, what is the value of p? That is what the question is simply saying. Because p is the premium, which is the amount in what? In dollars. So what is going to be that premium? So we're just going to substitute now what we have. So p, which is our premium, is equal to 5 times the square root of y. Here we are given that y is 49, which is the number of years, so it's square root of 49, times d, which is the number of dependents. How many dependents we have? There are 4. Okay, so p is going to be 5 times square root of 49, which is 7, times 4. So this is paper 2. If you do not know anything, use your calculator. So we're just going to put our calculator aside here. So we put 5 times 7 times 4. So we're going to obtain what? 140. So this is going to be p, which is 140. Remember, p representing what? The money in dollars here. P dollars. Take note, this is p dollars. So our answer for p is supposed to be in dollars. So therefore, our answer in dollars is going to be $140. But remember how we're given the dollars with 2 digits after the comma. So it's just writing the format of money, which is 2 decimal places. But even if you write it as 140, it's fine. They're going to mark that place. So guys, do you see how variation can be given? You have to be very, very careful with your questions, how you are given your questions under variation, connecting your variations. Is it joint? Is it partial, or whatever type of variation? I worked on variation, so make sure that you watch the videos on variation so that at least you can understand much better on that one. Okay, so let us see the other part, which is question number 5. Question number 5, you are given Mrs. Shoko decides to erect a jura wall around a rectangular standing. Okay, it's a rectangular stand measuring, oh, it's a stand. Okay, the way I'm reading it now, it's like a stand. Okay, it's a stand measuring 20 meters by 11 meters. 3 meters are on the left side, on the left for the gate. Okay, are to be left for the, okay, sorry for that. Let me reread again. Mrs. Shoko decides to erect a jura wall around a rectangular stand measuring 20 meters by 11 meters. 3 meters are to be left for a gate. So which means there's a gate that is going to be there and it is what? 3 meters. Okay. Find the perimeter of the jura wall. She has two options, A and B. Okay, so we need the perimeter. So this is what is happening, guys. This one you're going to see it later on, but it's a jura wall that is going to be made here. So it's like this. This is your jura wall. All right. So 3 meters are going to be left for the what? For the gate. So now we do not know where these 3 meters are going to be left from. Are they going to be left from this side or from the other side? But when you are dealing with perimeter, it's not in effect. You can leave it from this side or you can leave it from the other side. But all you just need is to know that there is a 3 meter which is there for the gate here. There's a 3 meter which is left for the what? For the gate, remember? So if this was 20 meters here, it means we are no longer having 20 meters. If this was 20, this is going to be 17 meters. We are now saying 20 minus 3, because from this point, we've got 3 meters for the what? For the gate. So this is your gate here, which is 3 meters. So it means out of 20, you're going to remain with 17. And this was 11, so this is 11, this is 11. So like I said, it depends with which way, which part are you going to remove? What are you going to remove the 3 meters? Are you going to remove from this side or from the other side? But it's going to look like this. Okay, so now the question is, what is the perimeter of the jura wall? We are looking at the perimeter of the jura wall, of which perimeter is the distance right round. So we are starting from this point, going through up to this point. So which means the gate is not going to be involved. So if you use this formula for perimeter to say perimeter is 2 into length plus width, whatever that you're going to get, you must remove 3 meters for the gate. You must subtract 3 meters on your answer. Okay, so that is what you're going to have, or you can just add your perimeter to say, since perimeter is distance right around the shape, you can just say your perimeter is going to be 17 meters plus from this point to this point is 11, plus from this point to this point is 20, plus from this point to this point is 11. That's your perimeter. Or you can use this one, then we have to subtract 3 meters, okay? So it's going to be 2 into length, that is 20, plus width, which is 11. Whatever that I get here, I have to subtract 3. Still, I'm going to have the same answer. So that means I'm going to have, we are going to have 2 by this one. If you add, okay, you can add first. That's 20 plus 11, which is 31. Then if you multiply by 2, it's going to be 62. So that would be 62 minus 3. Okay, so you can just subtract here, that's 62 minus 3, which is going to give us 59. Okay, so this is going to be 59 meters. So it's perimeter. Perimeter is measured in meters. So it's the same thing. If we could have just added this, we must get 59. Let's just cross-check. Are we having 59 here? I want to just take this side. Okay, so let's see. We've got 17 plus 11 plus 20 plus 11. Okay, so if we add, you're going to get 59, which is the same answer here. Okay, so that was it, guys. As you can see, it's actually nothing here. Okay, so let it save. Okay, it is saved. I hope it is saved. Okay, now let's move on to the other part now on B. So on B now we are being given that, okay, find the perimeter. We have the perimeter now. So she has got 2 options that she's going to make. Okay, these are the 2 options. She has 2 options, option A and B, to consider for erecting the what? The jura wall. Option A, okay, well, this is option A. She could engage a contractor who charges $12 per meter on a fixed and supply basis. So for each, it's going to be $12 per watt per meter. So that is what we can hear from that. Okay, so what is the question? Calculate the total cost for erecting the Jura wall using option A. So to erect the Jura wall, remember the perimeter of the Jura wall is the one that you're going to use, but per each meter is charging $12 per each meter. So it simply means the cost here is going to be, the total cost is just going to be what? The number of meters that we had for the Jura wall. Remember our Jura wall is what? 59 meters. So it's going to be 59 meters here. So our Jura wall is going to be 59 meters times the cost per meter. Remember the cost per meter is what? It's $12. So it's going to be times 12. Okay, so 59 times 12. You can just put this aside here. So it's 59 by 12. Okay, which is going to give us $708. Okay, so this is going to be $708. So that's what you're going to obtain from what? From the first option. Remember, these are two options that we are given. So we want to see now the second option that we have so that it can actually help us on this one. All right, so let's see what, or even this one, you can write as dollars like this. Okay, I can even put the zero. Some they just want to see this, so it's fine. There's no problem. Okay, so that was the first option. Now let's consider the second option, which is option B now. On option B, this is what is going to happen. She could buy the following material as shown in the table below and engage a builder who charges $100 for the job. So which means to just erect the job, the builder needs $100 if this material is being provided. Okay, so what is the material? We are given this, and the question on C now is to calculate the total cost for erecting the Jura wall using option B, which is this option B that we are given, or of charges. Okay, so what is going to happen on our option B? This is what is going to happen. Let us start with the bricks. We are going to have the bricks that are going to be used. Okay, so the bricks here, it's 5,000 which are needed. 5,000 bricks, but for 1,000, we are going to charge $80 per 1,000. So what about for these 5,000? So it's simple proportion. You can use simple proportion, guys. So it's going to be 5,000 over the number of bricks which are charged per 1,000. So it's pay, you divide by 1,000 times the money for that 1,000, which is $80. Okay, so this can cancel here. 5 times 80, which is something like what? 400. I'm not mistaken. Oh, but we have our calculator here. 5 by 80, that's 80. You know, it's comma here, so 80 is here, which is 400. Okay, so that's 400 that we are having. All right, anyways, it's fine. I'm just going to zoom a little bit. Yeah, I think it's clear. If this one is clear a little bit, yeah, clear. All right, so that is what we had from the bricks. Then we move on to the cement that is needed. So the bricks are done. The cement is 10 times 50 kg. So which means we need 10 50 kg bags. Okay, but it's $10 per bag. Each bag requires $10. And how many are they? There are 10 bags that we need. So it's going to be 10 times $10, which is $100. So we need $100 for the cement. Then the brick force, we need 5 bundles, but it's $5 per bundle. So it's going to be 5 times $5, which is $25. Okay, so it's going to be $25. Then pit sand, we are going to need 2 loads, and it's $30 per load. So it's going to be 2 loads times the amount, which is $30, and this is going to give us $60. Okay, so now this is what we have. So we are going to add the total cost for everything now. So the total cost, what is the total cost now for erecting the Jura wall? Remembering that the builder needs $100 for the job, which is this $100 is just for the job if you provide this. So the total is going, we are going to start with the money for the builder, which is 100. We move on to those amounts, which is 400. We're going to add 400 plus 100, okay, plus 25 plus 60. Okay, so if we add properly, we are going to obtain something like 585. So let's see, 100 plus 400 plus 100 again, plus 25 plus 60. All right, so we add everything, that's 685. All right, which means it costs less to use. If you buy your own material, see, it costs less, 685. Okay, 685 or 585 is 685. I just hope we have got all the values. Okay, so make sure that you include this one. So it's 685. Okay. All right, that's 685 here. Okay, so that is what we had, not 585, but 685. So it means I didn't include this 100, but the 100 is there. Okay, so that is what we had. So which means on option B, 685. Then on the part D now, what Mrs. Shoko decides to use cheaper option. And what is the cheaper option? Let's cross check on our options. The first option gave us $708. The second option gave us 685 plus. So which means she decided to use this option. That is what the question is saying. Okay. So what is the question now asking us to do? Calculate the amount she saves by using that option. What is she going to save? So to save, guys, okay, this is what is happening. She was supposed to pay $708, but now she's paying $685. So she saved how much? So you just subtract $708 minus $685. Then we can see how much did she save. Okay, so that's 708 minus 685. So if we subtract 685, we are going to obtain 23. So she only saved $23. Okay, so that's $23 like that. So this is the amount of money that she is going to save from that information that we are given before. So please, guys, make sure that you understand, take your information properly. By doing so, you're going to see that it's actually nothing. So that's what we had on this part, which is our B. I don't know. Yeah, just cross-check if there are some parts that you are not understanding, or maybe just if some errors. Guys, this is maths. A small error can lead to misunderstanding of everything. So let us know if there are errors or miscalculation, but that is what we're going to have in this case. All right. So number 6, construction. So there we are now given, this is construction, guys, where we have got answered all of this question on a sheet of plain paper, use ruler and compasses for all construction lines and show clearly all construction lines and arcs. So we are using ruler and compasses only. A triangular field has dimensions PQ 30 meters, PQR 60 degrees, and RPQ 45 degrees. So what are you going to do here? We're just going to remember, guys, I told you whenever you're doing construction, make sure you start with a sketch. Just have your sketch that is going to help you to construct this. Okay. So on the sketch here, we've got two angles, 45 and 60. And these angles, they're supposed to be on the base. So definitely, guys, our triangle, guys, this is just a triangle, 60 degrees. We can just assume where we want our 60 degrees to be, whatever side. So it just depends. So I'm just going to have my 45 here. So this will be my 60 degrees as for me, and this will be my 45 degrees. But 60 degrees is on what? Q, angle Q, the one that is indicated on top. You can see the angle here on top is Q. So this is our Q, which is 60 degrees. So this is your Q here. And 45 degrees is at what? At P. P is the one that is 45 degrees. So this is your P here. So definitely this becomes our R. So it's R, P, Q, triangle R, P, Q. And we are given that PQ is 30 meters. From P to Q is 30 meters. So this is a sketch, but we are given here a scale for 1 centimeter representing 3 meters. So whenever we see a centimeter, we see 3 meters. So which means what about 30 meters? We're going to divide 30 meters divided by 3, which is going to give us 10. So our answer here, we're going to have 10 centimeters. So instead of us having 30 meters here, we are going to have what? We are going to have 3 meters. Let me just reduce this a little bit. Okay, so maybe somewhere here, so it's no longer erasing, saving. Okay, guys, it's fine. So after some time, it saves. Okay, after some time, it has to save. So I just have to wait for it. Okay, so we said we are going to have 10 centimeters instead of what? 30 meters, because we do not have like 30 on our diagram. Okay, so that is the first thing that you're supposed to write, 1 centimeter to represent what? 3 meters. So that is what you have to indicate so that the examiner knows what you're doing. Okay, so this is our sketch, guys. So definitely we have to construct, because the question is now using this construct triangle PQ, and 6 marks guys to construct a triangle. Just imagine a lot of marks for construction just to construct this triangle, 6 marks. Okay, so anyways, let us have our triangle being constructed. We can just use utilize this space here. All right, so on this one, I'm not going to change like the dimension like what I did on those spaces where I was now ending up we having dimensions which are not exact. Here I'm just going to use as it is. So I just need these two aside. I'm just going to take these two. Okay. So remember your construction, guys, start always from a line. So you're going to start from a line, and from this line, I'm just going to. Is it possible to reshift? But it's not. But it's fine, guys. We are. I'm just going to show you what actually we have, because here is going to be another thing here. All right. So let me just have it as 0 degrees. Okay, so it must be at 0 here. Okay, so like I said, I'm just going to construct a line of my choice. Here's just a line that you're going to construct at first. Okay, so let's just have your line. Construct a line of your choice. So as you can see, guys, we've got 2 points that you're going to work with, which are the major points, which is point P and point Q. So I'm just going to mark the first point to be P. So this way my P is going to be located. I'm just going to mark to say, okay, this is our P here. So if this is your P at this point, then what does it mean? If this is your P, from P to Q, there is what? Let us cross check here. From P to Q is 10 centimeters. So you're going to measure 10 centimeters. So guys, what you do is go on your ruler, measure 10 centimeters. So on this of mine, my 10 centimeters is going to be like somewhere here. It's not like accurately 10 centimeters. This one is just, but you measure 10 centimeters direct, guys, okay, from your ruler. So here I'm just going to use this as my 10 centimeters, but you're supposed to measure directly on your ruler 10 centimeters. You mark a point like this. So this is where your Q is located. So this is just for you to understand, but do the exact thing on your diagram there. Okay, so this is your Q. So now let's consider the P. At P, we are supposed to construct 45 degrees. Where do we get 45 degrees? Remember, from 90 degrees divided by 2, that's 45. So which means I'm supposed to bisect 90 degrees. So we have to construct 90 degrees first at P. Remember how you construct 90, guys? I told you that you have to mark a point of your choice. You're going to mark a point here and another point on this side. And with these 2 points, you're just going to shift back to these 2 points, open more than half of the line like this is more than half. Then we construct an arc on top and another arc on the bottom. So there's no need actually for you to do that. Construct arc on the top and arc on the bottom. Just construct on the top there, since we've got a reference line that you're going to use. So I'm just going to construct another arc back here. So since this is construction, guys, let me just try to shift a little bit our thickness. Okay, so something like that. Okay, so our thickness is now, I think, fine. So we join this, but it's supposed to be a broken line because we do not need actually this line. So I'm just going to use a broken line. Okay, so join these 2 points here. They are enough to have our 90 here. Just join those 2 points. They are enough for your construction. Okay, so make sure join properly these ones with a broken line. So since we do not need this, let it be a broken line. Now it's too much thick, guys. I wanted it to be thick, but it's now too much. But I hope we see. Okay, I hope we see that. Okay, so this is where we are having our 90 degrees. Therefore, let us bisect. Remember to bisect this angle. We have to step where this point. Remember, our 45 is supposed to be inside the triangle on this side. So we are going to bisect on this side, which is on the right hand side. Okay, so this is where we are going to bisect. So just at this point, step at this point, open more than here, just open a distance of your choice where you're going to mark. Okay, because you need to mark on these 2 lines. So just open a distance of your choice. Okay, so I'm just going to change the marker so that it can work nicer for us. Which one can I use? Even black. No, black is already there. Let's use blue. Okay, so I'm just going to mark an arc. Let me just get a little bit back here. Okay, so I mark an arc on this side. I also have to mark an arc on this other side of the line here. Okay, guys, now this thing is now, okay, so, okay, it's fine. I'm just going to shift maybe this page so that a little bit higher here. Okay, a little bit. Okay, so they do not change the distance. So I'm going back here. So because I have changed my distance here when I was trying to shift. So let me check if it didn't affect. Okay, let's get back. It was there, this one. Okay, so what you do, we are going to mark an arc on the other side here. Okay, so that's an arc that we have. So these 2 arcs, where you see these 2 arcs, you have to mark an arc, step on those arcs. Okay, mark an arc in within the region there. So just mark an arc in within, just like this. Okay, we get back to the other point here, mark an arc also back to that point like this. So as you can see, these 2 points, they meet at a certain point here. Where these two meet, join back to what? To this point here. Okay, so it's gonna be 2. Okay, so let's just hope it's not going to waste much of our time here. Okay, so let's try to join. I think these 2 points can work. Oh, it's supposed to be 225. It's 225. Okay, these points can join like this. Okay, so join these points. Okay, we can just use our red since it's the one that we're using for diagram. So make sure that this is continuous now. Okay, so this is now a continuous line. So this is 45 and this is also 45 degrees. So that's your 45 degrees inside. Okay, then at Q, what is happening at Q, you're supposed to construct 60 degrees. So 60 is direct. 60 degrees, guys, as we know, is we just need to mark at point Q here. This side, okay, okay, I need to just shift like this. Okay, so on this side, we are supposed to mark as since our 60 is on the left side, so I just need an arc, which is like a semicircle actually from this point, just roll something like a semicircle. All right, then without changing the distance that you use, you have to mark back here on this side, where these two are going to meet, that is where you're going to have what? The 60. So where these two meet like this, you just have to join. Okay, so that's where we are going to have what? Our 60 degrees. Okay, so that's it, guys. Just simple like that. Okay, so this is not, I just need it here, guys. Okay. All right, let's just hope I'm going to be able to carry this one out. Okay, so guys, you see these instruments you need. Okay, so let me just bring back my ruler because now it is affecting me. Okay, so where is that ruler? Here. All right, so I'm just going to shift 60. All right, so this is where we need our 60 here. Okay, so just a little bit, I think it can work at 300 somewhere there. So on yours, guys, it's not going to take you much time, but yeah, I have to be specific. You see these instruments, okay, but it's somewhere at this point you join them. Okay, so now here is just a continuous line. You're not bisecting any angle, it's direct the 60 that you want. Okay, so this is your 60 degrees. So you just have to indicate that this is your 60 degrees. And we said from P to Q is 10 centimeters. So that is your diagram. So as you can see, these angles, the angle of 45 degrees and this angle of 60 degrees, they meet at a certain point here. Where these two meet, that is your point R. So this is where your R is, where these two meet. Okay, so now you have the point R. So that is what your diagram was going to look like. Okay, so just like that, guys. B, a well is to be dug in the field. Remember, our field is a triangular field, which means a well has to be inside this triangle. Okay, this is where the well is supposed to be. It's supposed to be inside the triangle. Okay, the question is construct. Okay, sorry. Inside okay, a well is to be dug in the field such that it is equidistant from P and Q and also 15 meters from R. Okay, so I want us to see what is happening here. We're asked to construct the locus of points which are equidistant from P, Q, and P. The equidistant part is nothing to about the well which is inside. No, it is nothing. Here we're just constructing the locus of points which are equidistant from P, Q, and PR. Remember, I told you guys from your locus, whenever you're given this, it means we need to bisect what is changing PQ, PR here. So which means this point is repeating at P. Okay. At P here, this P is repeating. Okay, so let me mark this at P. This angle P is repeating. So you're going to bisect angle P. PQ, PR, even let's check our diagram here. PQ, this is our PQ here. P to Q, P to R. So you're supposed to bisect the angle P. So remember how you bisect your angle, just like what we did on the previous one. We are bisecting P to R and P to Q. So you just open a distance of your choice that you're going on these lines. So you just have to mark on those lines. Okay, so I think the blue one can work. So I'm just going to mark an arc here. So just like what I did on the previous part, I have to mark also an arc on this line. Okay, So from those arcs that we have, these are the arcs, mark a distance inside the region. That is from this, you have to mark a distance inside the region here. From this side again, at the point of intersection where you need to point is, you have to mark back to this arc. So mark back like this. Okay, so as you can see, these two, they meet at a point here. So from where these two meet, we have to join them. Okay, so here's our ruler. We have to get back our ruler so that we can join these two. All right, so that's it. So let us join. Just going to have something like this. Yeah, is it going to join? Oh no, let's just all right, so you just have to join, guys, where it is somewhere specific there. I don't know if it is clear or not. So also practice, guys. Practice makes all these things to be perfect. So it's maybe somewhere here. All right, a little bit, yeah, somewhere there. So you can even join these ones. I'm just going to make it bold a little bit here. So since it's a bisector, I'm just going to put it this way. Okay, so this is the bisector that we are having. It has bisected our angle into two equal parts. So this is the line bisector that we needed. So it's an angle bisector. So take note of your construction, guys. Make sure that you watch the video on Locus where I explained the loci, all the loci that we have. Okay, then 15 meters from R. Okay, so we need 15 meters from R. Okay, so from R here, it's a circle. Remember, locus of points equidistant from a fixed point. That's what? That's a circle. So this one, we need a circle. So we need a circle from what? From R here. This is our R here. So 15 meters. Remember, we are given a scale. 1 centimeter represents 3 meters. 15 meters, we divide by what? By 3, which is going to be 5 centimeters. So you must draw a circle of 5 centimeters from what? From R. So this is what you're going to do. Since here we are supposed to measure, actually we're supposed to measure, but here I can simply see here, this is 3,8, as you can see. So I can just measure 5, this is my 5 centimeters. So according to you, make sure you measure properly, guys, by your 5 centimeters. Okay, so at point R there, once you have that 5 centimeters, you draw a circle like this. So as you can see, that is the locus of point equidistant from what? Equidistant from R. 15 meters from R, it's a fixed point, so you're going to have a circle like this. Okay, so now at the end, let us check what is happening here. So if we are to cross check on this one, the question on C now is to mark and label point W, the position of the well. So the position now, we are going back now where we are told that the well is supposed to be dug in the field. So which means we need the position of the well is given by these two possible combinations, that angle bisector and the circle that we had, but we must take a point of intersection which is inside the field. Okay, so inside the field, which is inside the triangle, we have got this point, which is, as you can see, these two meet here inside the triangle at this point. So this is where your W is going to be located, not this point because it's outside of the triangle. So you're going to take this one. So that is your answer there. So you just indicate the point, then you write W. Okay, so that's it. Then now find the actual distance of the well from Q. So you have to measure. This is the actual, we need the actual distance. So from our diagram, we do not have actual distance. Why? Because our diagram is in centimeters. So you measure first in centimeters, then whatever that you get, you multiply by 3. So it's distance of the well. This is your well inside the triangle from Q. So you measure from Q. What is the distance? So here I'm just going to use that instrument since it is the one that was giving me like the dimensions here. So I'm just going to take here and see what we have from W here to Q. It is giving me something like 5,6. So that is 5,6 centimeters. Okay. So that means with my 5,6 centimeters, I'm going to multiply 5,6 times 3. Since we are supposed to write our answers in meters, so you now use that scale. So 5,6 here times 3, that's as a decimal is 16,8. So it's going to be 16,8 meters. So remember your scale supposed to be given back in meters. Okay, so as you can see, guys, it was actually nothing construction. We just needed your points to be well presented. I think with that way, it can actually work properly. All right, so let's just cross check the other part, guys, that we are given, which is question 7. Okay, so question 7, we are given a farmer is a square orchard. So this is a square that we are given here. Okay, so it's in the form of a square, which is an orchard, as you can see. And this square is 10 meters. This one, this is the orchard, which is 10, 10, 10. So it's a square. Remember, the square, all sides are equal. So from this point to this point is 10, from this point is 10, also 10, like this. Okay, so he now decides to extend it by increasing the length of one side by x. So this one was increased by x and the other one by 2x as shown in the diagram. So as you can see, it's an increase, which means from this point up to this point now, it is going to be 10 plus 2x. So this one is going to be 10 plus 2x. It's now a rectangle. And this one from 10 up to x plus that x is going to be 10 plus what? 10 plus x, which is a rectangle. Okay, so that is what we had. And the question on A is to write down an expression for the total area of the extended orchard and show that it simplifies to. Take note, this is the area of the extended orchard that we are talking about. Okay, so the extended orchard is this one, which has got 10 plus 2x and 10 plus x, and it's a rectangle. So this one, we know that it's a rectangle. And area, okay, sorry, okay, so I need this. So area of a rectangle, you know, that is equivalent to length times width. So which means our area is going to be length, which is 10 plus 2x, which is the same as also this side. It will be also 10 plus what? 2x. So it's going to be length, which is 10 plus 2x multiplied by the width. The width is 10 plus x. So this is what you're going to have. So as you can see, guys, it's just a matter of expanding brackets. Then you can simplify further, which is area 10 by 10, that is 100, 10 by x, which is 10x, 2x times 10, that is 20x, then 2x times x, which is 2x squared. Okay, so as you can see, it's a quadratic expression where we just have to write it in the form of ax squared plus bx plus c. So which means we can start with x squared here, which is going to be 2x squared. We move on to x, so we've got 10x plus 20x. So these are like terms, so 10 plus 20, that is 30x. Then the constant, which is 100. So that is what we're going to have in this. All right, so you have to be on your answer. So I think this part is clear. So that was our item A, just using this part. Okay, so let's move on to the B part. Write down and simplify an expression for the area of the extension. So take note, the extension now is this part that we added. We now need the extension, which is this part that we added here. This is the extension. So what is the area of this part that I'm indicating here? So in order for us to find this part, we are just going to take, remember, we had the area of the extended orchard, which means including this square, which was already before. So what are you going to simply do? We are going to subtract the area of the square from that extended area, which we simplified and gave us 2x squared plus 30x plus 100, which is this one. We simplified it. So what we're going to simply do, we are going to simply subtract the area of a square, of which you know that area of a square is side squared or side times side. So it's going to be 10 squared, which is 10 times 10. So that means we're going to have our area as 2x squared plus 30x plus 100 minus 10 squared, which is 100. So as we can see here, 100 minus 100, that's a 0. So it's going to be 2x squared plus 30x. So this is going to be the area now of the extended, or of the extension. So this is your extension, this one, an extension which was given. All right, so that was the area of the extension. Then C, given that the area is increased by 87,5. Form an equation and show, okay, so they're saying this area was increased by 87,5. So show that it's going to give us this. So remember, this is the extension that you're given. So you're simply equating that extension because we have got the area of the extension already, which we said is 2x squared plus 30x. This is the area of the extension. So if this is the area of the extension, it means this area is equal to 87,5 because it was extended by what? It was increased by 87,5. So you're going to equate this to 87,5. So by doing this, guys, the quadratic equation, transpose this to the left-hand side, is going to be 2x squared plus 30x minus 87.5, then you equate to 0. So this is what they simply needed here. Show that it's going to reduce to this part. That is what we have shown, just 2 marks for that. Okay, then let us move on to D, solve the equation. So guys, it's now you and your equation. You are given the equation. So if you failed to show this, but you can't use that answer that is wrong, you have to use this one that you are given in case you didn't manage to get the actual answer. So you're going to solve this equation. So 2x squared plus 30x minus 87.5. How are we going to solve this equation? We can use our quadratic formula. Since we've got a, our a in this case is the equivalent of x squared, which is 2. Our b is 30. Our c is the constant, which is negative 87.5. Okay, so this is what you're going to have. So from your quadratic formula, what is our quadratic formula? Remember, the formula is given by x is equivalent to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Okay, so x is equivalent to minus b. Our b is 30 here, so it's negative 30 plus or minus the square root of b squared, which is 30 squared. So it's going to be 30 squared minus 4a. Our a is 2, so it's 2 times c, which is negative 87.5. Okay, so this is what you have. The square root covers everything, and the division line must cover everything up to the last part. Then you divide by 2 times a, which is 2 times 2. So this is what you have. Your a is 2 here. So guys, it's now you and your calculator on simplifying. So x is going to be equal to, so this is what you're going to do. I want you to simplify this part under the square root, only this part which is under the square root here, from 30 up to this. Do not put the square root, just simplify that part under the square root. So how do you simplify this? We just need our calculator. Insert your values. Okay, so from your calculator here, we are going to have 30 squared. So just open a bracket, insert 30, close the bracket. That is 30 squared minus, you multiply. So it's 4 times 2 times negative. So this is the negative that you use, not the minus, but this one for sign. So it's negative 87.5. Okay, so that's what you're going to obtain, which is 1,600. So you're going to obtain 1,600 here. All right, that's 1,600. Everything over 2 times 2, which is 4. All right, so from this part I can separate, but lucky enough we can obtain the square root of 600 here. Okay, so the square root of 600, it's simply the square root of the answer. Square root of answer is 40, so which means we can get 40 from that square root. So which means our x here is going to be equal to minus 30 plus or minus 40 over what? Over 4. But if you can't simplify, just separate with the square root, like maybe square root of 5, you just separate plus or minus. But in this case, we can simplify. So you can simplify it. Then after, now you can determine your what? Your square root. Okay, so let us just give it some time, guys. It must not stop. Okay, so because it will be saving this and that, so we just have to give it some time. I think now it's clear. So like I was saying, do not yes, you can simplify, but I just avoid in some cases where you are not given some conditions to work with. Just simplify as you can. Okay, so that's it, guys. Let us just insert our values here. We can separate. Okay, I just want to move this a little bit. Okay, it's not allowing me to move. So, guys, this thing has to save after some time. Okay, so I'm just going to write it here. X is equivalent to minus 30 plus 40. So we separate that 40. So it's plus 40 over 4, or another one is going to be x is equivalent to minus 30 minus what? Minus 40, everything over 4. So this one you can simplify on your calculator direct here. Let us just put aside. I'm just going to put a fraction. So it's negative 30 plus 40. Whatever that I get here, I have to divide by 4. So it's going to be 5 over 2, or as a decimal is 2,5. So depending with what you have, so it's going to be 2,5, or x is equal to, here I just have to remove the positive there and put a negative. So since I'm now at negative, delete this, put a minus. So it's negative 35 over 2, or negative 17,5. So this is negative 17,5. So that is what we're given to solve. Okay, so guys, be very, very clear about the question that you'll be given. Then the question is now, write down the actual area of the extended orchard. Take note, the extended orchard is this one that we calculated here. Write down in an expression for the total area of the extended orchard, which shows this one. This is the numerical. Now we need the actual value. So where are we going to get it from? The values of x that we calculated here. But remember, x cannot be a negative. So which means we are going to use x as what? As 2,5. All right. So this is what you're going to do on this formula. On this area that we had in this case, write down the actual length. Okay, guys, we need the length, not the area, just the length. Okay, guys, we need the length of the extended orchard. Okay, our extended orchard is this one. Okay, so the length here is 10 plus 2. This is the bigger side. 10 plus x, guys, is smaller, so it's 10 plus 2x. So we're going to substitute in 10 plus what? 2x. That is the length. The length is longer side. Okay, so your length here is 10 plus what? 10 plus 2x in terms of x. So we have got our x here. So we're just going to substitute that x. So our length is going to be 10 plus 2 times x. We use the positive, and our positive is 2,5. Okay, so which means our length is going to be 10 plus 2 times 2,5, which is 5. And if we add, we're going to have 15 meters. Those units were in meters. So that is the actual length of the extended orchard. If it was the actual area, you substitute on the expression for the area, but it was length. And the width, this is the width now, the shorter side, which is 10 plus x. So the width, in case they wanted also to calculate the width, if it was the width is the smaller side, which is 10 plus x. So it's going to be 10 plus x, which is 2,5, which is 12,5. So as you can see, this is the smaller side. So this is your width, this is your length. But the question wanted the length, so our answer is what? 15 meters. Okay, so let's see the other question. Which is now question 8. So question 8 is transformation. We are given a question on transformation. They answered all of this question on a sheet of graph paper. A triangle, PQR, yes, vertices 8. We are given the vertices P, which is 1, 1, 3, 4, whatever that you have, using a scale of 2 centimeters to represent 2 units on both axes, which means on the x-axis, you're going to use 2, 4, 6 on both axes, okay? Draw and label triangle PQR. So this one is direct. We just have to draw, mark your points. So P, remember our P was 1, 1. So this is the scale that I'm having. Let me just show you the whole of this part. Maybe it can help us. So this is our graph here from minus 10 up to 10. Then here, put 2 centers, 2 units like that. Okay, so this is my diagram. So it means 5 boxes, they represent 1. So this is 1 here, this is 2, 3, 4, 5, 6, 7, 8, 9. So it's like 5 boxes is 1. So it's same thing here, 1, 2, 3 in between, something like that. Okay, so the first point was P, which is 1, 1. So it's in between 0 and 2, that's 1, 1. So you count 5 boxes in between, 5 boxes in between, you mark your point. Okay, so this is your P. Okay, we move on to Q. If you saw Q, it was 3, 4. So Q was 3, 4. So that was 3, 4 here. So you mark your point Q, and R was 4, 0. So you mark your point 4, 0 here. That's your point R. Okay, so after doing this, we have to join our shape. Yes, I'm just going to take the ruler. If it takes time, then but I just hope it's not going to waste much of our time in trying to join these. Okay, just like this. All right, so make sure that you join your points properly there. So just somewhere here. All right, I think something like this can enable us. So guys, here I'm just going to take time because of these points, they are not exact. So it now needs me to, you see guys, something which is not exact. But as for you, it doesn't take you time because you have got everything on your fingertip, the ruler, everything, you have it there. So just not going to take you time. So here, it's like this. All right. Then from these ones, I have to join the last 2. All right, like this. All right, so this is what I'm going to have at the end. Okay, so this is my triangle, PQR, this one. Okay, so you just draw your triangle, okay? So this one, I'm just going to shade it. Is the first triangle, which is my object. You're not supposed to shade. I'm just shading so that you can clearly see our triangle. So this is the first triangle that you're given. You mark your points. Okay, so let's get back to the other question and see what you're given. B, we are given that Triangle PQR is mapped onto triangle P1Q1R by a transformation N. So N is a transformation, and that N is represented by this matrix. So you're supposed to know which matrix is this. As you can see, this is matrix for rotation of 180 degrees. Yes, you're supposed to know your matrix size. Okay. Anyways, item 1, draw and label triangle P1Q13 R1. So remember, guys, I told you whenever you're given a matrix, whenever you're given a matrix, you are supposed to use this concept. Matrix times object should give you the image. So the matrix is -1, 0, 0, -1 times the object, which is PQR. You're taking these coordinates of P. So this is your PQR like that. You write in matrix form. So P is 1, 1. So that's 1, 1. Q is 3, 4. R here is 4, 0. Okay, so that's it, guys. When multiplying, it's row by column. So let us multiply -1 times 1. That's -1 plus 0. -1 times 3 on this column. So it's -1 times 3, which is -3, plus 0 times 4, which is 0. We move on to the last column. So it's -1 times 4, which is -4 plus 0 times 0, that's a 0 here. Okay, so we move on to the last row, but starting with the first column, this one. So it's 0 times 1, that's 0 plus -1 times 1, which is -1. We move on to the other column, which is this one. So we're going to multiply again, 0 times 3, that's 0 here, plus -1 times 4, which is -4. Then we move on to the last column. So it's going to be 0 times 4, which is 0, plus -1 times 0, which is a 0. So you add this. Okay, so if we add, what are you going to get? -1 plus 1, that's -1. -3, -4, -1, -4, 0 there. So these are the points that you're having P1, Q1, R1. And I told you guys, you are supposed to write the coordinates before you talk about sketching. So you're supposed to write them properly. P1, -1, -1, Q1, -3, -4, R1, -4, 0. Okay, so these are the points that you're going to mark now on your graph, because the question is to draw, not to give the coordinates, but you're supposed to draw. So -1, -1, that's our P1. So let us mark. I'm just going to increase a little bit. Okay, so we put -1, -1 in between again, -1 here, -2, -3, -4, -5. So it's the same concept. So we need -1 versus -1, which is somewhere here. So that's your P1, okay? Our Q1 was -3, -4. So -3, -4, which is here. That's our Q1. Then R1 was -4, 0, which is -4, 0 here. That's your R1. So just like what we did from the previous case, we just have to join our points here. All right, so that's it, guys. As you can see, you can just join from this point to this point. Okay, then join also Q1 to P1 here. All right, so somewhere, is it gonna be fine? Okay, let me just put back the marker. Okay, it saves. So guys, let us just wait and see if it is going to save. Let's just hope it's not going to take this page down, guys, because when it starts to do this, it means it has a lot of things which are being written. So we just hope it's not going to take out our graph. Okay, anyways, this is what I'm going to have. Rotate this. Okay, something. Okay, I think here it's fine. Okay, just a little bit. Okay, so this is what I'm going to have. Join these two. Okay, like this. Okay, so as you can see, actually you can tell this is actually a rotation of 180 degrees if you are to see properly here. Remember your rotation, what you do, you join corresponding points, P to P1, R to R1 here. As you can see, they're going to pass through 0, 0, all these points, but you're not supposed to join. You are supposed to just draw, leave it like that. Okay, so all these parts, you're not supposed to even indicate them. Okay, so just draw. That's what the question was asking you to do. Okay, so that's it, guys. Let us get back to the other question. Now the question is, describe fully the single transformation represented by matrix N. You are describing the matrix, which is this matrix. As you can see, we say it is a rotation. So already, when you were using this, you already know that is a rotation. So that is now your description. So what are you going to write? It is a rotation. So remember, I'll describe rotation. It is a rotation. All right, what is the center? We know that this matrix is used when the center is 0, 0. So center 0, 0. Then the angle of rotation, we already talked about it, angle 180 degrees, which is the angle of what? Rotation. So 3 marks for describing that. We are done. So maybe if it is not clear, therefore you're supposed to join. If you join P to P1 here, you join those. We are now describing R. As you can see, Q to Q1 is going to pass through the same line. R to R1 here, it passes through this point. It's a straight line. R to R1, as you can see, guys, it's in a straight line. So as you can see, they pass through 0, and all these points, they meet at one point. And I told you it's a special type of rotation if you are dealing with isomet where all the points, they pass at one point. It means that's your center, and our center is the origin, which is 0, 0. So that's 180. So it's a rotation, center 100, angle 180 degrees. So you could have described from the diagram or to describe from the matrix, so many ways. Okay, let's see the other part of this question. On item C, we are now given triangle PQR, which is that triangle that we had before, is mapped onto triangle P2Q2. But I want us to see what is happening by a translation T, which is represented with the translation vector, and then followed by the transformation N, which is our N, is that transformation that we had of a matrix here, the one that we had our matrix here. So we have got two transformations that are taking place. We have got a translation. So let us start with the first one because it started with translation. So first is a translation. So remember, how do you find an image under translation? We know that translation vector is equal to image minus object. So this time we need the image. So which means I'm going to make image to be the subject of the formula. So how do I make image to be the subject of the formula? I just have to transpose the object to the other side of the equation. So it's going to be translation vector plus what? The object. So TV plus object should give us what? The image. So that means the image is going to be the translation vector. We are given the translation vector is what? 5 minus 2. So it's 5 minus 2 plus the object. So we are dealing with the object. We are treating each point separately from PQR. So remember your PQR, P, point Q, point R. You write the way that we did on the previous way in matrix form, but you are dealing with each point separately. So this is what you do. You write your points as usual, those points as they are. All right, so P was 1, 1. So P is 1, 1. Q is 3, 4. R is 4, 0. Okay, so these are the points, then we add. So what are we doing? We are adding to the point this vector to P, this vector to Q. That is what is happening here. So let us add and see what you're going to have. So it's 5 plus 1, which is 6. Minus 2 plus 1, that's negative 1. We move on, 5 plus 3, which is 8. Minus 2 plus 4, which is 2. 5 plus 4, that's 9. Minus 2 plus 0, which is minus 2. So this is what you're supposed to get as our image. So here there's no need for us to write these as points because it's still a continuation. There is another transformation, which is what? Followed by transformation N, and N is this matrix that we are given. So remember, whenever you're given a matrix, I said for you to find the image, matrix times object is going to give you the image. So already in matrix form like that, you're not going to change anything, still in matrix form. Now we are going to have our second transformation, which is the given matrix now, which is matrix N. So you're going to multiply by matrix N. Remember, matrix N, matrix times object should give us the image. All right. So matrix N, remember your matrix N was minus 1 is 0, 0, minus 1. So you multiply to the object. So this was the image from the first transformation. Now it's acting as an object because there's another transformation. So it's now an object. So you have to multiply as it is 6 minus 1, 8, 2, 9 minus 2. So just like what we did, guys, we all know what we did, row by column, it's just a repetition. So if you saw properly, minus 1 was just multiplying the top, minus 1 times 6, which is minus 6, minus 1 times 8, which is minus 8, minus 1 times 9, which is negative 9. 0 multiplies everything on top. So minus 1 is going to multiply these numbers in the bottom. So it's minus 1 and minus 1, which is a positive 1, minus 1 and 2, that's negative 2, minus 1 and negative 2, which is positive 2. So this is now your image, which is P2 Q2, R2. So all the transformations has been used. So now we can write as coordinates now to say this is going to be negative 6, 1. Q2 is going to be negative 8, negative 2. And our R2 is going to be negative 9, 2. Okay, so the question was to calculate, guys, you must answer the question. The question is asking you to calculate the coordinates of the vertices. So these are the coordinates that we have listed here. These are the coordinates, okay? So it's done. Then the last part now is to draw on item, to draw that triangle P2, Q2, R2. So now we have to draw our triangle from these vertices that we have. Let us draw our triangle. Remember your points, guys, okay? So I'm just going to just a little bit. So we have got negative, P2 was negative 6, 1. Okay, so that was negative 6, 1. Just going to mark a point here. Negative 6, 1 is on top here. So that's our P2. Okay, our Q2 was negative 9, 2. If we still remember, it was negative 9. So this is negative 7, negative 8, negative 9. So negative 9 is here. And versus 2, we mark our point. So this is Q2. And R2 was negative 8, negative 2. So negative 8, negative 2 here. That's our R2. So from there, we have our shape, which is the triangle. So we can join. Okay, so let us join here from Q to this point, and move on to this one. So as you can see, guys, it's just now a matter of what? Of joining the points. So this is what you're going to have at the end. Okay, then I can rotate to this one here. Okay, just a little bit from this side. Okay, so we join our points like this. We are done. So that was the question, guys. Oh, what happened there? Okay, like this. So like this, we are done. So as you can see, guys, that was the question. Yes, a rotation. It was a translation followed by a rotation. So that is what our diagrams is going to look like. So guys, we have to make sure that you revise your questions properly, understand what you're given, the information. All right, so 12 marks, just like that. We've got 12 marks. So I don't know, guys, how we actually see this, but I think this question was a little bit fair. Yeah, it was a little bit fair if you cross-check 12 marks for this, because we do not have any shear or any enlargement or any stretch. It was all about isometry. These were all isometries, 12 marks for isometries. So, okay, let's see the other part, which is now on question 9. All right, so question 9, we are given, answer the whole of this question on a sheet of plain paper. So this one, they need us to answer on a sheet of plain paper. All right, anyways, so that's where we are going to answer your question. The table shows the number of books borrowed from a university library in 1 week. Find the total number of books borrowed in that week. So you just have to add 30 plus 45 plus 25 plus 20 plus 60. We add everything, that is the total. Okay, so we're going to obtain 180 if we add properly. Okay, so let's, it's all right. So let's just leave it to save for some time. I just wish we finish everything. That's my wish, guys, because now it is now giving a lot. So it's 30 plus 45 plus 25 plus 20 plus 60, like this. All right, so you're going to obtain 180. So that's 180 here, okay? The B part, express the number of theory of education books, which is the theory of education, this one, as a fraction of all the books borrowed. Take note in its first term. So it's just, how many theory books are there? There are 60. So just see it, guys. So this is your B. Theory books, there are 60. Out of the number of books, how many books do I have? There are 180, just like that. You can simplify. So on your calculator, 60 over 180 is going to give us what? That's what we need. So it's 60 here over 180. So it's going to give us 1 over 3. So that's 1 over 3 here. That's as a fraction. If they said percentage, you multiply by percentage, but it was a fraction, so just leave it like that. Okay, then the other part now is show this information on a clearly labeled pie chart. Okay, guys, remember, if you are to draw a pie chart, okay, you have to list each angle for each part, okay? So a pie chart is just a sector. which is the circle which is divided into what? Into sectors. So each sector is supposed to be taken with a corresponding angle. Okay, so this is what you're going to do. You're going to calculate each angle for each book that was borrowed in this case. Okay, so you're going to calculate each angle. So you're going to start with the geography. So geography here, how many books did we borrow for geography? Is that, remember our total here, our total was 180 degrees. So to find the theta, which is the angle of what? Of a sector. So theta, the angle of a sector is given by this formula. I'm just going to write it here. Theta, the angle of a sector, is the frequency for that book or that portion that you're talking about over the total frequency. Whatever you get, you multiply to 360. Remember, it's a circle, so angles add up to 360. So it means for geography, we are saying what is the total, what is the frequency for geography? The number of books for geography is 30. So which means our theta is going to be 30 over the total, which is 180. Total frequency is 180 times 360 degrees. Okay, so from your calculator, you can simplify this. That's 30 over 180 degrees. Whatever that I get here, I have to multiply by 360. Okay, so I'm going to obtain 60 degrees. Okay, so that's 60 degrees. So geography here is got 60 degrees. We move on to science. So our science here is got a total of 45. So it's the same 45 over 180, sorry, over 180 times 360. So we just say it's a repetition. As you can see, guys, it's just 45 here. I'm just going to move this up to 45. Okay, so this 45 here, and that's 90 degrees. So as you can see, you're going to go 90 degrees. So that's 9. So you do this up to the last one. So guys, do not waste much time. Let us quickly, let us just take from this. Maths is 25. So you're just going to substitute in place of maths, substitute 25 here. So delete this and put 25. So it's 50%. So this one, 50 degrees, sorry, not percent. So this is 50 degrees. Shorter is 20. So you have to move on to shorter, which is 20 here. Okay, so that's 20, which is 40 degrees. You're going to have 40 degrees. Theory of education is 60. So it's 60 over the total. So you're just going to take here and remove this and put 60 here. So it's 60 over the total, which is 120. So you put, so that's what you simply have. So these angles now are the ones that you're going to indicate on your pie chart. So how do you draw a pie chart? That is the question. Okay. So this is what you need on a pie chart, guys. You are going to draw a circle of your choice. Okay. So this is what you're going to have. Which means we need our instruments here, which is the compass. Okay, so with my compass here, I'm just going to draw a circle of my choice, like this one. Yeah, something like this. I hope it's fine. Even somewhere here. Okay, somewhere like this. So you just have a need to point here. So you can even mark, since here we need that reference point. So I'm just going to okay, guys. I'm just going to mark the first point here to say this is where I want my point to start at. Okay, so using this point now, which is this one, you're going to just draw a circle of your choice. Okay, so that's a circle of your choice. And from this circle of your choice that you have, this is no longer needed. What you're going to do is to mark the first point of your choice from the center to the circle. Okay, so you mark the first point where you're going to take the angles from. So these angles, they are taken in one direction. Okay, so this is what you're going to do. You just mark a point, which is your reference point, your reference line, I mean. So this is your reference line from the center to the circle like this. Okay, so now it depends with you. Are you going to take your angles in the anti-clockwise direction or in the clockwise direction? Okay, but you're supposed to follow one order throughout the end. Okay, so in this case, I'm just going to take the anti-clockwise direction. So you choose any of your choice. Okay, so working from the anti-clockwise direction, the first angle that I'm supposed to indicate is this one. According to it, it's 60 degrees. So that's my first angle for geography, which is 60 degrees. Okay, so I have to measure 60 degrees from this, since I decided to use anti-clockwise direction. So this is what I'm going to do. You put your protractor. Your protractor, do we have protractor there? Yeah, protractor is there. So we take our protractor here, make sure that you place it on this part here. It has to be on the center. This where there's a plus here, it must be on the center. So you put it on the center like this. Okay, so this one, you can even increase it, yeah, like this. You can even, okay. So what I want you to see is this part on the center there. So, and this line has to be covered. As you can see, your angles, they are starting at what? These angles, they're starting 0 here, going in this direction. So which means I choose to use the anti-clockwise. So which means I'm taking these angles here, 0, 10, 20, 30, 40, 50, 60, because I'm going in the anti-clockwise. So my 60 is occurring at this point here. This is where I'm having my 60. So I just mark a point at 60 there. Okay. So this is where I'm having 60 degrees. So using your ruler now, you join from the center to that point now, passing that point. Okay. So let's just reduce our ruler. Okay. So you have to join from this point here to that point that we have marked on our circle. But when you are marking, make sure you join now straight and to the what? To the circle. You do not exceed your circle. You join straight to the circle like that. Okay. Sometimes this point might be outside of the shape. It depends with your compass. I mean your protractor there. It might be outside of the shape. You just join, because it's a ruler, it's a straight line. When you join straight to that point, but you do not exceed outside of what? Outside of the shape. You just draw inside. So like this, guys, you join from the center to that point like this, okay, to the circle. So once it reaches the circle, you're done. Okay, this is my center and I am having my angle here. You do not write my angle, okay, the angle, say, okay, this is 60 degrees. No, the one that is going to mark is going to measure this angle. So now what you just do, you just write what is that part. This is geograph. So you can just write geograph inside. Do not write the angle. There's no need, because the examiner is going to put the protractor and measure this angle. Okay. So now we have moved from the reference line from this point, which was our reference line. Remember, this was our reference line, this one, okay? So now we are no longer coming back here because we are moving in the anti-clockwise. Now I am on this line. So I'm going to take this line now, which is now from this reference line. This is where I'm going to put my protractor and measure the next angle that is going to come. So I'm just going to rotate this, okay, until I have it on this reference line like this, okay? Just make sure that it covers everything at 0 there. Okay, something like this. It must start at the 0 like that. Okay, so this is now like your reference line. Okay, the one that it had to zoom like a little bit when I saw that. I don't know how did I do it for it to zoom. Oh no, I don't want it to be like this. Okay, just want it to zoom in. Okay, like this. So it must cover this point, guys. The point has to be here and 0 starting at that. Okay, so which angle are we measuring? Let us get back. It's okay. This means I am supposed to take this, guys. Okay, our angle is what here? Our angle is 90 degrees. Okay, so we're supposed to measure 90 degrees. Okay, so let's get back here. Okay, it was like this. So 90 degrees, still moving in the anti-clockwise. As you can see, our 90 is direct here, straight at 90 here, straight at this point. This is where we've got our 90 degrees. Okay, so in this case, it is joined, but I didn't want it to join like what it did. Okay, anyways, it just joined, but that's what you're going to do anyways. So you have to just join those points from that point where you marked that point. Okay, then you join just like what we're doing. Okay, guys, let it save a little bit. No, it must not close this page, guys. We actually need this page. All right, so I'm just going to join. I'm just going to join here. Okay, now my ruler, guys. No, I don't want to do this. I want to pick this ruler here. Okay, guys, let's just be patient enough, guys. You know, these instruments and these softwares, you have to try by all means to be very, very patient. Okay, so anyways, if you join, it was going to look like this. Okay, so this is where you are now having your 90. So this is 90 degrees from this point to this point. And this is actually indicating or representing what? What is it? This is sines. So this is sines. Okay, so you just write inside sines. All right, then we move on to the other one, which is now maths, and maths is 50 degrees. So this is now your reference line. We are now at this line. So you have to make sure that your compass, your protractor here, has to be in that line. Okay, so let's just rotate until it covers this line here. So make sure that it's here and it starts from this point, which is at 0. Okay, so we need 50 degrees in the anti-clockwise, 10, 20, 30, 40, 50. 50 is somewhere here. So where your 50 is, which is at this point here, that's where our 50 is. You just mark a point, then you join from the center, just like what we're doing from the previous case. Okay, so that's what you're going to do here. Join. Okay, so you just have to join here. All right, so that's something like this. Okay, something like this. Okay, then you join these two. Okay, so I'm just going to join to the center, just like that. Okay, so this is what was it? 50 degrees was maths. Okay, remember this was maths. So maths, which is mathematics. Okay, then we are done. We move on to the other one, which is Shona. Shona, it's 40 degrees. So you're going to measure 40 degrees from maths. Now we are now at this line. So make sure that your protractor has to be from maths now. Okay, so no, it's supposed to increase. Okay, so somewhere here at the center, then you just have to start at 0 now. Yeah, it is covered. It's now started 0. Okay, so we said our angle is 40 degrees for sure. So 40 is somewhere here. This is your 40 here. Just mark a point at 40 there. Okay, now it has drawn the line. Anyways, it's fine. So what I needed was just a point. Anyways, you just have to join from that point. All right, so something like this, from this point to the circle. So your points should be taken to the circle. Always they should be taken to the what? To the circle. Okay, so something like this, you just have to join until you meet the circle somewhere there. Okay, so that's what you're going to have. And the last part, that is the theory of education, which is 120. So definitely, guys, this was our Shona here. This was our Shona here. So definitely the last part is your theory of education. So this is theory of what? Of education. Let's just measure and see if it is going to give us that 120. So we just have to rotate like this. Yeah, it's 120. As you can see from 0 here, it's 120, or you can rotate it like this. Either way, you can rotate. As I'm still new to use this thing here. It's like this. Okay, like this one. Okay, so you can rotate until it can cover here. Okay, so let's rotate again at this point. Where is that? Okay, rotation. Okay, like this. So as you can see here, it is covered. No, it's not at 0. So it must start at 0, direct at 0. Where is that? Okay, like this. Yeah, a little bit. Yeah, okay, like that one. So as you can see, it has covered our line. It starts at 0 here. So 0, 10, 20, 30, 40, 50, 60, 70, 110 up to 120. As you can see, this line, it passes through 120. That is to show you that your diagram is correct. If your diagram is wrong, it is not going to give you 120. But there is that assumption that they're going to like an approximation plus or minus 0.1 degrees. So it must not pass this. Let it be in within that one. Okay, so that was your pie chart. So that's how you end up with pie chart. And pie chart, it's under ungrouped information. So that's the way you have a pie chart. So I think, yeah, that's what we had, and it's clear. So 6 marks for that. Okay, then D. 2 students borrowed books from the library. So take note, how many students are there? There are 2, okay? Calculate the probability that the first student borrowed a science book and the second a maths book. So these 2 students, they borrowed from different sections. The first one borrowed a science book. How many science books do we have? Okay, so you have to cross-check here. The science books, they are 45. Remember, probability is what we have. So probability, that's the 45 here. So we're going to have 45 over the total number of students. Remember, we said we put 180 students times. We are picking a second, which is a different book. So the number of books is not going to change for maths. It's going to remain as it is, which is what? 25. Remember, maths, they are 25. But the total is going to be affected. So this will be 25 over. This was the first student that we picked. So out of 180 students, now we are going to remain with 179 students. So you just subtract 1, that is what you're going to have. So if you multiply this properly, you're going to obtain 25 over 75, if I'm not mistaken. So let's just multiply 45 over 180, whatever that we get here, we multiply to 25 over 179. Okay, so this is going to give us 25 over 716. Okay, so that's what you're going to have. 25 over 716. Is it 716 or 715? is 716. Okay, so that was the probability and you're done. 12 marks for everything, statistics. So this was statistics that we are actually given. So that was your question 9. As you can see, guys, with this part of a pie chart, everything. So pie chart, calculate your angles first, then indicate your angles using a protractor. Okay, so that is the idea there. All right, then let's see the other question, which is question 10. On question 10, this is a velocity time graph because we're given here velocity in terms of our time. The answer to this question on a sheet of graph paper, the velocity v meters per second of a moving body at time t seconds is given by the formula v is equal to t, whatever that you have. Below is an incomplete values of what? Of v. So as you can see here, yes, someone was trying, so it's a scanned paper, so that's why you see the answers m is 5, n is what? 9. But how did we get these answers? We are going to substitute when t is equal to 0, what is our v? So that's what you simply do. So the first one, t is 0, so you substitute when t is 0 here, which means our v is going to be what? 5. Then when t is 4, we substitute here, v is going to be, in place of t, we substitute 4. So this is going to be 4 squared minus 3 times 4 plus 5, like this. Okay, so you can just substitute on your calculator straight here. So that's going to be 4 squared. Okay, that's 4 squared. Okay, minus 3 times 4. So you can just even open bracket and multiply this inside the bracket. 3 times 4 plus 5. Okay, this is plus 5 like this. So it's going to be 9. As you can see, it's 9 there. So that's where we are getting our 9. Okay, so these are the values of m and n that we are asked to find on item A. Then the B part, we are now given from this table that we have, which is the velocity, using a scale of 2 centimeters to represent 1 unit on the horizontal axis and 2 centimeters on the vertical, or 5 meters per second. Draw the t. Remember, guys, I talked about this on the velocity time graph. If you never watched that video, make sure that you watch the video on velocity time graph. I talked about how you represent this. So it's just like a quadratic graph. Everything you're going to produce just the same way as a quadratic graph. So you need to mark the points first. Okay, so this is our scale. The graph I'm already inserted here. This is velocity in meters per second. We are given 2 centimeters. Representing 5, so that's what you're going to have here, 2 centimeters on the V. So it means according to scale here, 2 boxes are going to represent 1. Like whenever we've got 2 boxes, that is where we've got our 1, 2 boxes, that's 2, 2 boxes, 3, and so forth. So each and every 2 boxes represent 1. But on the horizontal, it means each box represents 0,1, 0,2, 0, something like that. Okay, so we just need to mark our points. Remember, the first point was 0,5. So we just have to mark those points as they are. The first point here is 0,5. Okay, so that's 0,5. We have to mark that one. Okay, so let's just see if it is going to be there now. Or did I select or did I not? Now I don't know, did I select or not? Okay, now I have exceeded. Okay, so 0,5. Oh, it's now on the other question. Let's get back to our question. So since it is taking time, I'm just going to mention those points direct because now it's taking time, as you can see. So 0,5 here, you mark your point 0,5. The other point was 1, 3, if I'm not mistaken, that was 1, 3. So it's 1 versus 3. So remember I said 2 boxes represents 1. So you're going to count main boxes, 6 boxes. That's your 3. So 3 is just going to be 6 boxes from this, which is 6 boxes. That's our 5, 6. According to me, that's my 1, 3 here. All right. So I'm going to mark that point here. 1, 3, count according to scale properly. The other point, what was following, it was 2, 3. You mark your points properly. Then 3, it was 3 versus 5. So 3 versus 5 here. You mark your point again, 3 versus 5. The other one was 4 versus 8. It was 9, 4 versus 9, if I'm not mistaken. That was 4 versus 9. So 9 is just 2 boxes below 10. This is 10 here. So 2 boxes below 10, that is where you're going to have your 9. Remember, 2 boxes represent 1. Then 5 was versus 15. So it's 5 versus 15. Then this is 15 here. So 5 versus 15. That is where we are having our 15 here. All right. So let's just move aside. And 6. 6 was versus 23, if I'm not mistaken. Okay, let's just cross-check back these ones. I'm not seeing them. Okay, so it's 6 versus 23 and 7 versus 33. Okay, so 6 versus 23. That's 6 here. 23, this is our trend. We have to reduce our graph a little bit. Okay, so 23 is actually above what? Above 20. So 6 boxes from 20. That is at 6 here. This is your 20. So 6 boxes. That is where you're going to have what? Your 23, because 2 boxes then what? Represent 1. Then we move on to 7 versus 33. So it's 7 here versus 33. So this is our 30. Okay, it's above, guys. 30 here. This is your 7. So 30 here. Okay, this is our 25. Our 30 is here. So 33 is 6 boxes again. After that 30, you just count 6 boxes, which means somewhere there. All right, so you make sure that the points are clearly presented like this. Then from there, using this, you're just going to join this. So guys, this one on joining part, just make sure that you join properly. But here now, because I can't even rotate this, but just going to try. That's the disadvantage that we have on this, because we can't rotate this page so that you can draw from another angle, but you just have to join properly, guys. Make sure. All right, then we move on to this one, to this point. Okay, yes, like this. It's too much here, it's too much there. Okay, anyways, guys, you just have to join. Okay, is make it smoother and so forth. Do not be, let it be not like this one. And after you're drawn your velocity time graph, make sure that you name the equation of that. Remember, V was equivalent to t squared minus 3t plus 5. So that's what we had. So that's it, guys. That's your velocity time graph. So as you can see, it maintains the same shape as a quadratic graph, just like what we had on the quadratic graph. So it can be easier like that. Okay, so after drawing the graph, let us see the questions. The other question now is asking us here to use your graph to estimate. Take note, guys, it's your graph that you are using. So, and it's an estimation that is taking place, which means your values, they are not exact, it's an estimation. So we want to estimate item 1, the values of t when v is 4. So we are given velocity. All right, so this is what you're going to do. From the velocity here, this is your velocity here. So where v is equal to 4, what are the values of t? So this is what you're going to do. Remember, this is your velocity. You're going to draw a horizontal line from v is equal to 4. Remember, v is equal to 4 is a horizontal line. Okay, because this is where we have our v, which is 5. So v is equal to 4, just 2 boxes below 5, because remember I said 2 boxes bend 1. So you draw a straight line from that 4, just draw a straight line to indicate the line of what? Of v is equal to 4. So this is what I'm going to draw. I'm going to draw here like this. Okay, so this is the line v is equal to 4. As you can see, it passes through 4. So where this line meets with your graph, okay, where this line meets with your graph, that's where you're going to take your answer. So here it meets at this point. That was the exact point. So you draw dotted lines down to the x-axis, to the t-axis, you get your time. Even to this point where these two meet, down to the x-axis, that is where you're going to have your answer. So according to scale, these are 3 boxes. So this is 0,3. According to scale, this is 2,5. So these are the values of t that we are having. Okay, so this was C item 1. So I'm just going to write it aside. Okay, so this is C item 1. Remember, these are the values of t. Okay, so C item 1, t is equal to, we said the first one is going to be 0,3. So it's 0,3 seconds, or another t is equal to what? 2,5. So it's 2,5 seconds. Okay, so these are the values of t representing time in seconds. Okay, so I think this one is fine. Let us move on to the other question. The acceleration at t is equal to what? 3, when t is equal to 3. Guys, I told you that acceleration, you do the same thing, the way that you calculated the gradient on a normal quadratic graph. Remember, when you had a quadratic graph, you calculated gradient. So the same way that you used to calculate gradient on a quadratic graph is the same way that you calculate acceleration, but you must know that acceleration is measured in what? Meters per square second. That is the only part that is important, but the way that you calculate that acceleration, you use gradient. Remember how to calculate gradient? You draw a tangent at this point where t is equal to 3. So where t is equal to 3, you're supposed to draw a tangent. Then from that tangent, we can be able to determine our gradient. So this is t is equal to 3. Where this meets the graph, it meets the graph at this point. A directed t is equal to 3, it meets the graph at this point. So we're going to draw a tangent to that point. Remember, a tangent, it just touches the graph. It does not enter inside. So it's just like this. Okay, so that's my tangent. This one, I just hope it's clear. I just hope it's clear. Okay, so from there, you draw your tangent, the mark, red, no, this is not nice. This is not nice at all. Okay, let me use the black one or the blue one. Okay, let's just pick. Okay, so this is our tangent here. You just draw a tangent. So a tangent, it just touches the graph. It does not enter like inside of the graph, just touches like this. Okay, so now you've got your tangent. What are we going to take? Okay, so this is C item 2. So we need the gradient. So remember gradient, you take points. And I told you that the first point that you're supposed to take is where t is 3, because that is where we drew our tangent here. So that is your first point. Remember, when t is equal to 3, our v is 5. So it's a point, this one, 3 versus 5. You pick another point on the line, not on the graph. So on the line here, I'm going to pick 4. So 4 is for this one, it's not actually direct the way that I actually expected it to be, because on the one that I had, it was actually 4 versus 8, something like that. So you just take a point which is corresponding, but according to what I had, it was actually at 8, something like that. So maybe it was supposed to be somewhere here, which was going to give us 8, but you take what is on your graph. Okay, so 4, 8 was my point. Actually, from what I did, it was 8. So that's what you're going to have in this case. So from this part here, remember, it's just gradient. Remember the way that you calculate your gradient, guys. Increase in y over increase in y over increase in x, which is y2 minus y1 over x2 minus x1. So y is 8 minus y1, which is 5, over x2, which is 4 minus 3. So 8 minus 5, that is 3, over 1, which is going to give us 3. So we calculated like gradient, but what are we calculating? This is acceleration. So therefore, acceleration is going to be 3 meters per square second. So acceleration is gradient. The same way that you calculate gradient is the same way that you calculate your acceleration. Just draw a suitable tangent, take 2 points from there, then you can be able to draw. So that was what we had, guys. Okay, so let's see the other part of the question, which is the distance. So here we need to calculate the distance now. The distance from t is equal to 4 to t is equal to 8. Remember, distance is area under the graph. That is your distance. You're going to simply calculating area under the graph. So that's what you're going to have. So from t is equal to 4 to t is equal to 8, which area are we having? So this is what you're going to need on your graph. T is equal to 4. So you just have to draw the line using your ruler. Straight to the graph. T is equal to 4. That's here, 4. So to the graph. So here we use the ruler, but here because of time, guys, it's going to take us a lot of time. So this is t is equal to 4. Up to t is equal to 6. Okay, so it's up to t is equal to 6. So 6 is here. So straight at 6 to the graph. Okay, so this is going to be straight to the graph. So this is where you've got your 6 here. So you need the area under this graph. Okay. So you calculate the number of boxes, all these boxes here, you calculate them properly. So here when I calculated mine, I got 632 on this region. So you calculate all the boxes within this region, okay? Within this region that I'm indicating here. You calculate everything within that region, okay? So it has started. No, do not respond, do not close, please. I just hope we are going to finish. Okay, so like I said, here I was having 632. So remember we said distance is area. So how do you calculate area? This is the formula for area. If you're given number of boxes, remember from your quadratic graph, our area was number of boxes over 100 times area of what? Area of unit square. So that's what you're going to have in this case. But this area here is your distance. So which means this is our item 3. So we are going to have this in place of area, but it's now distance. So distance traveled is going to be number of boxes. Like I said here, you use the number of boxes from your graph, but on mine here I got 632. Okay, so it's going to be 632 over 100 times the area of the unity square. Remember, your unity square, guys, is this part here. That is your unity square. The first graph, on the first graph here, the square that you see, it has got 5 and 1. This is the area of the square. The first square that you see, that one, that is the area of the square. So here it's 5, here it's 1. So 5 times 1 is 5. Okay, so you just multiply 5 and 1. Here I'm just indicating, but just multiply 5 and 1, you get what? You get 5. Okay, so that is the area of the unity square. We got a 5. So we're going to multiply by 5. So it's 630. So it depends with what you got on the number of boxes, but here I'm just going to use this one as a reference. So 632 over 100, whatever that I get here, I have to multiply by 5, and that's going to give us something like 31.6. Okay, so this is our area, which is 31.6. So this is 31.6. Remember, distance is measured in meters. Yes, you are calculating area, but it's distance, so it must be in its units, which is what? Which is meters. So that was the question, guys. As you can see, that was the question that was enabling us to actually have 12 marks for everything on the velocity time graph. So it's very, very important, guys, that you know the information that you are given and how to work with this graph. Know all the graphs. It actually helps you. Okay, so guys, as you can see, it's actually pretty clear. So we are going to focus now on question number 11. From that part, we are going to see what actually we are given from. Right, so let's just see this part, and we can solve whatever that you're given. You're given that a regular polygon. Take note, this is a what? A regular polygon. Here we are working with a regular polygon. Yes, an interior angle that is twice its exterior. That is the exterior angle. Find the number of sides of the polygon. Okay, so there are some of the things that we actually need to understand the relationship. Remember, I talked about relationship between the exterior angle and the interior angle of a polygon, that these two, they are actually found on a straight line. So you can work with the sum of interior, or you can simply use this relationship. I don't know which one was going to be best for you. If this is a polygon, okay, let's just say this is a polygon that is going to be there, I don't know, until it is closed. We know that this is our interior angle, which is the angle that is inside of the polygon, and the one that is outside is the exterior angle. All right, so now according to this part, we are given that the interior angle that is twice. So the interior angle is twice the exterior angle. Okay, so in this case, let's say our exterior angle is x. Okay, we are just saying our exterior angle is x. We are told that the interior is twice the exterior. So which means twice is going to be 2 times x, which is what? Which is 2x, that is twice. So twice is 2 times. So which means this is going to be 2x. So by this relationship, we know that this is a straight line because these two are on a straight line. So if I add these two, I'm supposed to obtain 180. So by doing this, I can actually solve for x, which x is going to give me the interior angle, because we said the exterior angle, sorry, because we said let the exterior angle be equal to x. So by solving for x, I'm solving for the exterior angle. I'm also solving for the interior angle. There, from there, we can find the number of sides. So this is the relationship because those two are on a straight line. So that's going to be 3x here. So 3x is equivalent to 180 divided by 3 divided by 3. So that means our x is going to be what? It's going to be 60. So x representing the exterior angle is 60 degrees. So we have got 60 degrees here. So this angle is 60 degrees. And this is 2 times x. 2 times x is 60. So 2 times 60 is 120 degrees. All right. Then from the regular part here, remember guys, I told you about the exterior angles, that for any polygon, the exterior angles, they're going to add up to 360 degrees. And it's a regular, meaning to say these exterior angles, they are equal. Here, we are going to have another 60. Here, we are going to have another 60. Here, we're going to have another, and so on and so on. So how many 60 degrees are we having? Those are the exterior angles. And the number of exterior angle correspond to the number of interior angle, and these correspond to the number of sides. So since we know this, they add up to 360 degrees, I'm going to divide by 60 degrees. And by dividing, I'm finding the number of sides. So 60 into 360 that's going to be something like 6. So which means this polygon has got 6 sides. So that is the relationship that we simply had. Or you can use the angle now. Since we know that the interior angle is 120 degrees, we can use this concept, finding number of what? Finding the sum, then this and that. So, but if you have to cross-check, the question about the sum is the one that they're asking. So which means, guys, we are supposed to actually work through this one is going to be best. Okay, now the sum, which is item 2, we want the sum. Remember the sum of interior angles for any polygon, whether it's regular or it's irregular, as long you're dealing with the number of, the sum, you use n minus 2 times 180 or 2n, or it can be the one for 90, so it will be 2n minus 4. So that's going to be 2n minus 4 times 90, if I'm not mistaken. So just cross-check your formula. Yeah, but something like that. Okay, so there we can substitute n, which is, remember we got that it has got 6 sides. So our n is 6. So 6 minus 2, that is 4. So it's going to be 4 times 180 degrees, of which if we multiply this, that's 4 times 180 degrees, which is going to give us 720. So this would be 720 degrees. Okay, so that was the question. And we've got 4 marks for everything. Okay, the B part, we are given a triangle, actually 2 triangles or 3 triangles, because we put 1, 2, and the bigger triangle. So from this information, we are given that in the diagram, A, B, C, and D lie on level ground. A, B, C is a straight road. So from A to B to C, it's a straight road, like coming from west to east, like that, okay? Which runs in the west-east direction. That is what you're given. Then AB being equal to BD is 9 kilometers. So these two are equal, which means this is an isosceles triangle. So these two are equal. And remember that from sides which are equal, the opposite angles, they're equal. So this angle that is opposite to this side is the same as this angle, which is opposed to this side. So this angle is going to be 40 degrees, okay? Then also we're given that angle 40 and BC is 6, which is this one that we're given, okay? So the first question, calculate the bearing of A from D, which means we are coming from D. This is where we are going to have our north pole. Remember, guys, how you find your bearing at D here. We are going to place a north pole at point D, okay? So if you are calculating a 3-figure bearing, which means we are going to take our bearing, remember I told you guys, from the north pole in a clockwise direction until you meet the line which is going to A, because we are given A from D. So the line, the angle has to be taken until it meets the line which goes to point A. So this is the angle that we are going to calculate. So what are we going to do? That is the question now. How are we going to find the whole angle that we are given there? So it's going to depend with what we have. If you have to cross-check here, there are some things that we can actually calculate. Remember, we are given that this is a straight road that we are given. So which means at A here, it's a straight line. It's a continuation in the west direction from the west, passing through A, and we can put a north pole like this, okay? At A, we can put a north pole because we are told that this goes in the west-east direction. So this is a continuation of a straight line. And we are given this angle is 40 degrees that we have got here because of our isosceles triangle. We say this angle is 40. But we know that from a north pole like this, the whole angle is 90 degrees, the whole of this angle. But we have got 40 degrees, which means the remaining, we can find this remaining angle, this one. From 90 degrees, we are going to subtract what? 40 degrees, which is going to give us 50 degrees. So that means this angle in between is 50 degrees. And I also told you that from the parallel lines, these north poles, they are going to be representing parallel lines. So that is what you're supposed to know actually if you're dealing with these north poles. Okay, guys, we are back to our story again. I hope we are going to win. We are just to, okay, so this is what you're going to have. So which means we are going back to the same criteria of the parallel lines because we've got the north pole here, or I just have to change the marker. I don't know. Okay, so this is a north pole, your north pole. So if this is, we are to draw a transverse here, which is the transversal line, we have got the Z angles and this and that, and which is happening here, which means here we're going to create a Z from this A to point D. This angle 50, and this angle at D here is going to be also 50 degrees, okay? We have determined this angle at D, this one, let me indicate it from D, this piece here is the one that we are saying is 50 degrees. And we know that from a straight line carries 180 degrees. So it's going to be 180 degrees plus 50 degrees. That is the bearing. And this is going to give us 230 degrees. So which means the bearing of A from D is going to be 230 degrees. All right, so that was it, guys. From this information, I think we saw what was actually happening. Yes, I'm just going to erase here because we are going to another question now. All right, so now we are given to calculate the distance CD. That is the question which is following on item 2. What is the distance CD? So let us cross-check from our diagram. Where do we have CD? So CD, that is this distance here from C to D. So as you can see, guys, we have got a non-right angle triangle, and this is a straight line, so we can find the remaining angle in this triangle, which is this one, so that at least we can know exactly what to use if we have an angle which is inside. So to find this angle from a straight line, that's 180 minus 40 degrees, which is 140 degrees. All right. So using the concept of, remember, guys, I told you about the issue of included angle, which is cosine rule. So here we're going to apply cosine rule since we've got included angle, and we want to calculate the side which is opposite to the included angle. So remember, our cosine states that we are just going to calculate it even here. So this is item 2. All right, so this is item 2. Remember, your cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos a, which is the one that you use whenever you're calculating what? You're calculating a side, whereby the b and the c are the sides which are creating the angle, which is in this case, we are talking of 9 and 6. So we want to calculate CD. So it's going to be CD squared. The side that we want to calculate is equal to 9 squared plus 6 squared. So you can start with any of these two sides, okay? So I'm just going to start with 9. So it's 9 squared plus 6 squared minus 2bc, which is the product of both sides again, 9 and 6. So it's going to be 2 times 9 times 6 times the cosine of the angle, which is between the sides, and this angle is 140 degrees. So from there, we can simplify. That is CD squared is equivalent to 9 squared, that is 81, plus 6 squared, that is 36, minus, we can multiply 2, that's 2 by 9 by 6, which is going to give us 108. So it's 108 cos 140 degrees. Okay, so let us simplify. CD squared is, if we are to add these two, that's 81 plus 36, 81 plus 36, which is going to give us 117. So that's 117 minus 108 cos of what? Cos of 140 degrees. Okay, now be very careful here. These two cannot be subtracted. So you have to start by multiplying according to your body mass. So these two, you just have to show the product of these two. Okay, so this is what you're going to do. You're going to write the CD squared as it is equal to 117 minus, you find the product of these two, which is 100. So make sure that your calculator shows a D there to show that it's in degree mode. Okay, so this is 108 cos 140 degrees. I can close the bracket, and that's negative 82 comma something. So you just have to show the value there of these two. Okay, so that's negative 108, negative 82. So it's negative 82 comma 732, something like that. Okay, so you write everything up to the last digit. Then now you can combine CD squared. So instead of adding these two, what are you going to do? You're just going to retake from this part that we were given here. We're just going to take this stage as it is, okay? So this is what you're going to do here. So you're going to take this stage as it is, insert this stage on your calculator as it is. So that is what you're going to have. So what am I trying to say? I'm going to have 117 minus 108 cos 140 degrees. So it's cos 140 degrees. I close the bracket. All right, so that is what I'm going to obtain, 119 comma something up to the end. So this is going to give us 119 comma 732, something like that, 32. So that was 3 2 something up to the end. You write everything. All right, then to find CD, then you're just going to introduce the square root, because this is squared. Remember how you remove the square root, introduce the square root both sides. So that's your CD. So CD is the square root of answer. So it's just square root of the answer that I was having, which is 14,13 and so forth and so forth. So it's 14,1326 and so forth. Okay, so remember your degree of accuracy, and whenever you're not given the degree of accuracy like this one, you just calculate CD. Your answer is going to be to 3 significant figures. I think I read the instructions at the beginning of the question paper. So CD is going to be to 3 SF. I'm going to count 3 digits, 1, 2, 3, 3 whole numbers. So as you can see, 3 is less than 4, so it cannot be able to round off this 1. So it's just going to remain as 14,1. Okay, then also take note of the units. The units here, we are given in kilometers, all these BC 6 kilometers, BD 9 kilometers. So those are the units that you're going to use. So our answer is in kilometers. So that's our CD, which is 14,1 kilometers, all right? Then we move on to the other part, which is the area. That is item 3, the area of triangle BCD. So let's cross-check our triangle. BCD. So this is a triangle BCD, and it's a non-right angle triangle. So remember, the area of a non-right angle triangle is given by area is equivalent to half of AB sine theta. Or some they use sine C sine, but it's half AB sine theta, which is the angle that is in between. And the A and the B are the sides which are creating this angle theta. So it's going to be half of, let's cross-check our triangle. What are the sides that are creating the angle of 140? Is this 9 and this 6. So it's half of 9 times 6 times sine of this angle, which is sine 140 degrees. All right. So it's going to be half of 140. Not 140. We said 6 and what? We had 6 and 9. Okay. That was 6 and 9 or 9 and 6. So it's half of 9 by 6 by sine the angle, which was 140 degrees. Okay, so that's it. You can reduce 2 into 6, that is 3. So we can multiply the 2 here, which is going to give us 9 times 3, that is 27 sine 140 degrees. Okay, so on your calculator, this can be simplified, guys. 27 sine 140. All right, so that's 27 sine, this is sine here, 140 degrees. Okay, so what are you going to get? 17 comma something like that. So that's our answer, 17,355, something like that up to the end. And to 3SF, that's going to be 17,4 square kilometers. So remember, area is measured in square units. So it will be 17,4 square kilometers. So that was the idea there. Okay, so as you can see, guys, that was 12 marks for everything on this question, 8 marks on this one, and the first 4 marks that we had on the interior, on the polygons, they were dealing with the interior and the sum of the interior angle, something like that. Okay, so let us cross-check the last part of the question, which is on vectors. Okay, in the diagram, ABC is a triangle. So you're given a triangle AB, you're given vector AB, which is Q, vector AC, which is P. M is the midpoint of AB. Take note, this M is the midpoint. So that means if this is the midpoint, from A to M, it's a half of AB. From M to B, it's half. So which means from A to M, our vector is going to be half Q. From M to B, our vector is going to be also half Q. That is, you divide this into 2 equal parts. But remember, because the whole of AB is vector Q. So they are going to be divided into 2 equal parts because it is the midpoint, okay? Then we are given X is a point on BC such that from B to X, that is B to X, is 4 units, and from X to C is 1 unit. So this is a ratio of 4:1. Okay, I have to just change the marker here. So guys, I'll just have to be patient enough. It has loaded a lot, like it wasn't expecting to finish up this question paper. So it has to save after some time. It saves like this. Okay, so just here we hope that we are going to finish up because that's we actually need here. All right, so we are back here. So I was saying this is actually 4 and the other one is 1. Okay, so let me just All right, so let's indicate here. So it's going to be 4, and this is going to be 1. Okay, now we are given and CM and AX intersects at Y, CM, okay, this one, they intersect at this point Y, okay? So this is just like 4 units. It's not like that's your vector, it's just a ratio, okay? So the first item on A, which is item 1, expressed in terms of P and or Q, which means our answer can carry P or Q, the vector BC. Okay, so what is our vector BC? We need a route that we're going to take from B to point C. Okay, so I can just even calculate it aside here. So that's our vector BC, which is our item 1. So vector BC, we can take a route from, we have to start with B. So we're going to start from B to A, then A to C. So BC is going to be BA, then plus from A to C. So the route has to be connected. You start with B, you end with C, you end with, so these two must also connect A, and A should connect. Okay, so let us find BA. From B to A, we are opposing the direction. Remember, we are given vector AB, which is Q, but BA is now going this direction, opposing the arrow, so it's going to be negative vector Q plus vector AC, which is maintaining the arrow. We are going this direction, which is the direction of the vector, so it is going to be vector P. So we can even start by writing P, since P is positive, which is going to be P minus Q. Okay, so that's our vector BC. All right, sorry for that. Let's cross check the other part, which is vector CX. So from C to X now, we are going to see this is C to X. Take note of the direction, C to X. And according to our ratio, CX has got one part according to the ratio, okay? Of the CB, the whole of this from C, both this has got one part and we've got 4 parts here. So 1 plus 4, that is 5. So which means our CX, because of the direction, CX is going to be one part out of 1 plus 4, which is 5. So it's going to be out of 5 of the whole line from C to X, which means we are going this direction, which means we are going to point what? To point B. So it's going to be 1/5 of vector CB, not C, but CB like this. Okay. But here we do not have CB. We found the vector BC. This one is vector BC, not CB. But remember, the relationship is that CB is simply a negative of this answer that you're given here. So you're just going to multiply by a negative and you take vector CB. So it's going to be minus 1/5 of vector BC. So it opposes what we have the moment you introduce a negative. So it will be minus 1/5 BC. Okay. So if it is minus 1/5 of BC and we have got vector BC here, which is P minus Q. So it means our vector CX is going to be negative 1/5 times vector BC, which we said is P minus Q. So that's it. Multiply by negative 1/5, negative 1/5 times P. That's negative 1/5 P. Negative 1/5 times negative, which is a positive. So it's positive 1/5 Q. So that is our vector CX. So that was simply what we needed, guys, from this one, our vector CX, just like that. Okay. Then we have got another part, which is item 3, that is vector CM. Okay, so let's cross check from our diagram CM. So we need a route that we are going to take from point C to M. Remember, we said M is the midpoint. So we can take any direction. We can use CB, we can use CA, then AM, since we have got all these values. Okay, so we need CM. So this is item 3. All right, so I'm going to take CM as from C to A, then A to B. So it's going to be CA plus A to M, sorry, not A to B, but A to M plus AM. Okay, so that is our vector CM. So that means in this case, let's just divide a little bit here. So we are going to have our vector CM, which is equivalent to CA. Let us cross check our direction. From C to A, we are opposing the direction this time. We are opposing our direction here. We are now going this way. Okay, so it's going to be negative P. So that would be negative vector P. That's negative vector P. Then A to M, as you can see, we are maintaining the direction this time. We are no longer having this. This time we are maintaining the direction. We are going the same way the arrow is going, but it's A to M, where M is the midpoint. So it's going to be half vector Q. So this is half of vector Q. That is your CM, just like that. Okay, so I think it was easier to, as you can see, guys. Then AX, what is the vector of A to X? Okay, let's cross check from our diagram. What can we take from A to X? So remember, we found the vector CX before. CX is there. So from A to X, we can simply take A to C, then C to X, since we have CX. Okay, so it's AC plus CX. That is our vector AX. Okay, so this is item 4. So you said vector AX is going to be A to C plus C to X. All right, whereby vector AC is A to C. Here we are maintaining the arrow because we're now going this direction like this. We are maintaining, so it's vector P. So this is going to be vector P. All right, which is a positive, so that's vector P plus CX. So CX, now we take the answer that we got here, because remember, you calculated your CX here, and this is what we got. We got negative 1/5, so it's negative 1/5 vector P, all right, plus 1/5 vector Q. So this is what we got here. So as you can see, these are just whole numbers, guys. So we are simply subtracting like terms, P and P. So it's 1 minus 1/5. So you can simply use the calculator as paper 2, 1 minus 1/5 like this. What we get? 4/5. So this is going to give us 4/5. So that's 4/5 vector P plus 1/5 vector Q. Okay, so this is your vector AX. And make sure that the first part of the vector, this part that you see, make sure the first part you write all things clearly on this first part. Make sure that everything is clear, because it's going to affect the other answers that you're going to have. Okay. Okay. Anyways, let us see the other part. Now we are given that here on item B, given that, you see what I was trying to say, this, you're now being affected. But the moment you're given something like this, given that CY is KCM, express CY in terms of P, Q, and K. So which means we are starting from this part that you are given here. Okay, so this is what we have. So this is our B. We are given that CY is equivalent to KCM. So I want you to see something. Already the CM, we have calculated the CM here. You cross-check this, your CM. All right, so this is item B. So we are given that CY is equal to KCM, and we calculated CM, which is this one. So we're going to multiply by K, which is the scalar. So our CM is negative P plus half of Q. So if we multiply this, is going to be K times minus P, which is minus KP, K times half of Q, which is half of KQ. So that's what you're going to have. And if you're multiplying your vector, you start by the scalar, then followed by the vector. So this is your answer in terms of what? In terms of P. So it was simply multiplying by K, then you are done, just like that. Okay. So let's cross-check another part of the question now here. So we are given another condition again. AY is equal to HAX, but express CY in terms of H. So this one we see we need CY again. So let us take the part that you're given first. We are given that AY, also this is item C. All right, we are given that AY is equivalent to KAX. This is what you're given. So do we have, it's H, not K. So this is H this time. All right, so this is H. So now we are asked to calculate vector CY. So, but we need to first find this, what we are given. The moment you're given that, find that part that you're given. So let us find first AY. So AY is equivalent to H times AX. Do we have AX? Yes, we have AX. We calculated our AX here, and we said AX is 4/5 this plus 1/5 Q. So this is what you're going to write. That's 4/5 P. All right, let's see. It has to save again. It has to save again. All right, so let us take our value here, which is HAX. We said our AX is what? 4/5. So I'm just going to write 4/5 vector P plus 1/5 Q. So that's what you're going to simply have, okay? So that's AY is equal to multiply by H each and every term. So it's going to be 4/5 H vector P, H times this one, which is going to be 1/5 H vector Q. Okay, so this is vector AY, but we are asked to calculate the vector CY. So our answer has to contain AY in order for our answer to to have h, because we are asked to express this in terms of h has to be there. So which means to have h, this is the only statement which has got h for now. So which means we have to include this vector that we are given, which is ay, so that our cy is going to also have what? Is also going to have h. All right, so this is what we're going to have. Let us take from this part ay, but we need to include, we need cy, but we need to include what? Ay. So which root are we going to take from c to y? But ay has to be there. So this is it. From c to y, this is what we need. But we are saying y has to be there. So what are we going to do? We are going to move from c to a, then from a to y, which means ay is involved. So we said ca plus ay. So that's what you're going to have in this case. Okay, so that's ca plus ay. So that's how we are going to find our cy. So cy is equal to ca plus ay. So that's ca plus ay. Okay, so ca, we have to take it from the diagram. So ca, as you can see, are simply opposing the direction from c to a. That's negative p. We talked about this previously. So that's a negative p. So it's going to be cy is equal to negative p plus ay. This is your vector ay here, which is plus 4 over 5 HP plus 1 over 5 H cubed. So that's what you're going to have in this case. All right. So from this part, I want you to take note here. I want you to take note. You are going to factor out a vector which is the same, not the scalar to say H is the same. No, you factor out a vector. Okay. So in this case, vector P is common. So I can factor out vector P here. Okay, but if I factor out, I write the brackets first, the vector outside of the bracket, like after the bracket. Okay, so if I factor out vector p here, it's minus p divided by p, I'm going to be left with minus 1. If I remove this vector p because it's the same, so if I factor out p, like I remove p here, I'm going to remain with what? With 4 over 5h. Okay, plus 1 over 5h cubed. So just like that, I've got my vector cy. So I can leave my answer in this format or like that. So you can't simplify these two, just leave it like that. Okay, so that was the idea there. Let us check the other part of the question. If we are to cross-check now, we are asked to using the results in B and C. So what do we have in B? In B, we calculated cy here in terms of K. In part C, we calculated the same cy, but this time in terms of H. So those are the results that you're going to take. You find the values of H and K, hence find AY in terms of P and Q, which means, okay, let us first find the values of H and K. Okay, that part we'll see it later on. So remember, guys, what I told you, to find the values of H and K, you have to find the two vectors which are the same. So here our B from B, this is your B here. This is what you calculated from B. We got CY. So we are going to say these two are the same. Okay, so these two are the same. CY, which is equal to negative KP plus half of KQ. And this CY that we just got now, which is negative 1 plus 4 over 5H, vector P plus 1 over 5H, vector Q. These two are equal. So if they are equal, what does it mean? It means I'm going to equate the vectors now, which is vector P and vector P are the same. So I'm going to take the constant, which is the scalar of negative K. So this is what I'm going to take, equate to the scalar of the same vector P, but of the other part, which is this one. So I'm going to equate my answer to negative 1 plus 4 over 5H. So I have formulated an equation here. So after formulating this equation, try by all means to at least simplify your equation, remove fractions, this and that. Okay, so I'm just going to leave it like this. We're going to simplify it further. Let us formulate another equation. Another equation, we are going to take it from Q. Take the coefficient of Q here, which is half K. So we're going to have half of K here equal to, from this vector Q, what do we have? We've got 1 over 5H. So we're going to have 1 over 5H. So that's another equation. Okay, so we have got two equations. I'm going to start with this one. Let us clear fractions on the first one. Here is same like over 1 over 1. So which means you're multiplying by 5 each and every term. Multiply here by 5, multiply here by 5, multiply here by 5. 5 times minus K, that's minus 5K, is equal to Negative 1 times 5, that's negative 5. H, 5 and 5 will cancel, so you're going to remain with positive 4h. Okay, so that's what you're going to have from the first equation. Then from this part, we can actually collect the terms. I don't know how we are going to write it, but you can just transpose, avoid working with negative, so I can transpose 5 to this side and transpose 5k to this side. Okay, so if I transpose 5 to the left-hand side, is going to be positive because it was a negative, is equal to negative 5k to the side of the right is going to be a positive, so it's going to be 5k plus 4h. So at least I can leave it like this. Okay, on this part, I can do the same, multiply by this time, the LCM of 2 and 5, that's 10. 2 times 5, that's 10. So you're going to multiply by 10, or you can cross multiply, whatever that you're going to have is fine. So 2 into 10, that is 5. 5 times 1k, that's 5k is equal to 5 into 10, that's 2. 2 times h, which is 2h. Okay, so here I'm going to formulate an equation. Take this to the other side of the equation. I'm going to formulate an equation. 5k minus 2h is equal to 0. Okay, of which here I've got an equation that I'm already given. 5k plus 4h is equal to what? Is equal to 5. So now I'm having two equations that I'm going to solve. So from these equations that I'm having now, let us solve for what? Let us solve for h and k. So how are we going to solve? Is now, guys, I don't know which method I'm going to use. What we need are the values of k. So I can eliminate here, since these two are the same, I can eliminate k, subtract 5 minus 5, that's a 0 here, minus 6, minus plus 4. So you can even use minus 2, sorry, you can even use a calculator, minus this one, 2, minus for subtraction, then you open bracket, we are subtracting what? 4. So you just put a bracket, it's a positive, so it's negative 6. So you're going to have negative 6h is equal to 0 minus 5, that's negative 5. So divide by negative 6 by negative 6. So this can cancel, h is equal to what? 5 over 6. All right, so I have the value of h. I can find now the value of k. All right, so this is what I'm going to do. Just equate from one of the equations. I don't know which one I'm going to take here, but I'm going to work with the first equation. 5k minus 2h is equal to 0 here. So it's going to be 5k minus 2 times h. Our h here is 5 over 6 is equal to 0. So you can multiply on your calculator, negative 2 times 5 over 6, like this. You're going to obtain negative 5 over 3. So that's negative 5 over 3. So 5k minus 5 over 3 is equal to 0. Okay, so 5k is equal to what? Transpose this to the other side is a positive 5 over 3. So what do I do to solve for k? Yes, you can cross multiply, it's fine. Whereby you can cross multiply here by 3, that's 15. So it's going to be 15k is equal to 1 times 5, which is 5. You can divide by 15 both sides. So your k is going to be 1 over 3. So here I used the longest way, guys. Anyways, there are so many ways that you can use. So this is your h, this is your k that we got. But remember, that was not the only thing that we are given. The other part of the question was now asking us to simplify or to have ay in terms of p and q. This is what we are now given here if you have to cross-check properly. Ay in terms of what? In terms of P and Q. So what you're going to do, you're going to take from any of these AYs that we got. Remember, we have got our AY. Is it N or is just one? It's just one, this one. This is our AY that we got here. So you're going to substitute into that AY, this one that we have given here. You still remember your AY that we obtained. So it's the way we are going to. So that means here, if we were to take this AY here, let us write our AY aside. So that AY as it was, guys, we just write it down. So this is a hence part, which means a continuation. Okay. So our AY from that part was given as AY was given as what? It was 4 over 5 HP plus 1 over 5 HQ. Okay, so take note, this is what we're given. So now from this AY, you can cross-check that it is in terms of H. So which means what you're supposed to substitute is H. So in place of H, we are going to substitute the H that you got, which is our H is what? 5 over 6. So that means our vector AY here is going to be like this. Okay, so our AY is going to be 4 over 5 times h, which is our h is what? 5 over 6 vector p, plus 1 over 5 times h. Our h in this case is still 5 over 6 times vector q. So this I'm simply saying times, that's what I mean. Okay, so this is your calculator. You can use your calculator or you can just divide here. I don't know what is best for you. So 4 over 5, okay, multiply by what? 5 over 4. 5 over 6 is going to be 2 over 3. So AY is going to be 2 over 3. So that's 2 over 3 vector P. I multiply these two plus it's going to be 1 over 5. So that's 1 over 5 here. Multiply by 5 over 6. So that is 5 over 6 like this, which is going to give us 1 over 6. So that's going to be 1 over 6 vector Q. Okay, so as you can see, guys, that's what we had from this part. And if you have to cross-check, all the information that we have from this question paper actually marks everything. So that's what you need, guys, in our revision. So let us try by all means to revise as much as we can till our final exams. So that's it, guys, for Maths on African Motives, working on O-level mathematics exams, past exam papers, revisions, topics, and all that we actually need to know in our syllabus. So if you are new, you can consider being part of the family by subscribing, and also don't forget to share our videos, guys, to your friends and colleagues so that they also can benefit from this information. So make sure we just share to others, guys. They need this information. They need to be part of the family so that we can all win as a family of Maths on African Motives. So that's it, guys. Till we meet again.